And to do that, we'll also cover why these different types of problems, because sometimes all the different types of real world application fall into one of these category, right? It could be, you could be working on automotive fuel, economy minimization or maximizing power. You could be working on, let's say, some mathematical problem, physics-based problem. So they can be categorized into different areas, right? So they might fall into one of these category. Okay. Now, having a system, let's say, if you have a system, if you talk about just an overview, so it can depend on various design variables, right? So you can have multiple design variables. If it is an electrical system, design variables could be, like what could be my resistance, inductance. If it is a mechanical system, it could be what is my mass, inertia, material properties, right? Similar to that. So you could basically feed some initial guess when you start working on optimization. You could actually feed an initial guess of design variables and to the system and check results. You can see, okay, if these are my variables, what would be my system performance? Okay. So if objectives weren't met, so we need a way of modifying the design variables. So this is what optimization routines are really good at. So they use information gathered from running the system and make educated decision about how to modify the design variables in order to improve the system. That is what an optimization does. And it is a closed loop process that can be iterated until the objectives are met, right? So let's say, take an example. This is how the design process will look like when you basically work on optimization. Okay, so you have initial design variables, you have a system in place, right? It could be any type of system that you can represent mathematically, and then you can have objectives that are met or not. So if they're not, you modify the design variables, right? So this is basically a closed loop scenario. And once you create this problem, you can iterate over and over again, right? So basically, to make sure that your objectives are met, basically. Okay. So why use optimization? Let's say. So also this question is very relevant. So first, I'm going to show you how I would go about optimizing a system if I didn't have an optimization routine, right? So if you don't have an optimization routine, how would you actually go about it? So this plot is from an automotive engine. Whatever you see right now is from an automotive engine and shows how the fuel efficiency measured by the colors is affected by engine rotation, speed in RPM, and the intake pressure. Okay, and we would like to maximize that fuel efficiency here. So what you see here is as the pressure, intake pressure goes high, so the fuel economy here is what we want to be in the red region. Okay, and this is the engine RPM. Right? So if we are in a low RPM or even high RPM, we might not have an optimal range, but during this RPM range and this pressure range, you get an optimum value here. Okay, so this is typically what you might have also experienced when you drive cars. Some of the automotive manufacturers, they put that you should drive your car in certain RPM range, in certain gear, so that to get maximum fuel economy, right? So let's imagine though that I don't have this map available, possibly because it would simply take too long to run my system at each point required to generate this plot. Okay, so start with initial guess, adjust the pressure ratio, one factor at a time. I could actually start here and adjust pressure and see what my optimization is. So this is all manual. So this is all like hit and trial method, right? We are doing it manually. So I can take another step and see how the performance is, actual economy is, like that, right? So you can reach a better point by adjusting pressure ratio and then get a better fuel economy. So what you can see is from here is, as you can see, that the T-shaped search pattern. So this is a T-shaped search pattern. This is how we have went. Okay, is basically we end up at a better result than we started, but we are unable to find the maximum fuel economy. Okay, so I showed this type of approach to raise a question: how do you know you have come to the best solution to your problems? That is why I showed this example. Right? So basically, you might start doing something manually, but you may not be sure that this is the best possible solution. Okay, so this type of approach is very common, especially when you take into account the cost of testing. Okay, so how can we use optimization techniques to help us find best solution? Okay, that is our question. Okay, so now these are the reasons why we should use optimization. Okay, so we need to find better design variables or the overall design. We need to faster the design evaluation. So in a shorter time, get the tuned in design system. Okay, and useful for trade-off analysis also. So once we do these analysis, we can also trade off, saying, okay, can I reduce this? Can I maximize that? Okay, this is costing more. Can I reduce some material and get an optimal design like that? Okay, and non-intuitive design may be found also, right? Something that way also. Okay, so to cover these things, we'll start with least squares minimization first. Okay, so what is this least square fitting? Okay, so here is the next problem. Okay, that I'd like to solve and show it in front of you. Okay, so given some data. Okay, so we have some t data, some y data. Okay, and we would like to fit a curve of the form shown here. In other words, find the values of the coefficient C1 and C2 from this equation that the results in to fit the data. Okay, so what we are going to use is a function called LSQ curve fit. Okay, so what I'll do is now shift to MATLAB. Okay, so what I've done is I'll also try to zoom in here. Okay. Let me zoom it a little bit so that everybody can see it. Okay. So what I'll do is I can zoom it like this. Okay. So first is, let me open this least squares example. Okay. As you can see here, we have set it up our MATLAB environment here. Okay, so this is our command window. This is really our folder browser, and this is our MATLAB script for that. Okay, so if I show you in zoomed screen here, okay, so you'll see a time plot, time data, a y data, that's a response data. Okay, and if we just want to look at this, we can just say in the new version of MATLAB, you can directly say run in advance. Okay, so these are all sections marked by %. So you can put %. It will create sections in your program. Okay, so that you can run one by one. Okay, so I'll run first. Okay, this section, and then next session. So it will give me all the data points. Okay, so I'm able to see what is my data. Okay, so there are basically 6 points here, 2 to 4, 6. Okay, so there are 6 points, and now I would like to do a curve fitting here. Okay, to do that, what I'll do is I'll dock it here. Okay, I'll put this here. Okay, so that's our okay, that's our graph here, points. Now, next thing what we have to do is, so since we are taking this example here, okay, so we want to check out with the plot tools what this looks like. Okay, we want to add a title to it. We can add. Yeah, hello. Yeah. Tell me.
The script is not visible to us.
The script is not visible.
Yes,
okay.
Sir. Please zoom in, sir.
Okay. Let me zoom it also a little bit. Okay, so I can do change preferences and editor display debugger. Okay, text editor. Fonts. So I can change the fonts to 18 and say apply. Is it better now? Or should I increase more? Okay. I think it should be visible now.
Yes, sir. Yes, sir.
Okay. So now what we are going to do is we are going to add this title to it. So you can, once this plot is created, you can add a title here. Okay. And once I run this section, you'll see this title added to it. Okay. So this title has been added here. Next thing is we want to do this curve fitting problem. Okay. So this problem is linear in coefficient. So let's set this up here. So what we can do is we can create ones basically. So E is that variable. We will create ones here. Okay. So what it will do is it will create these two columns with initial values of this function. Okay, and then we can directly solve like this. So you can say all the coefficients is equal to the E results by the equation itself. So once I run this, okay, so you'll see the two coefficients here basically. Okay, so these are our C1 and C2. Okay, this is how you do it. And to check that fit, you can actually run it and plot it. So you can run this equation and plot it over top of that. Okay, so what we'll see is this is the curve fit part here. Okay, so this line is from the curve fitted model that we created, okay, using that C1 and C2 as a coefficient. Okay. What about the constraints, let's say, right? So we could also include certain constraints here. Let's say the values of C1 and C2 should be within this range, right? That is also something that we would like to do. Okay, so you might have already seen it, or for people who have not seen it, there is also a function called LSQ_lin. Okay, so this will do constrained curve fitting. So there is an open curve fitting that I earlier showed. Right? So for that, what you do is you can directly use this function here, LSQ curve fit. Okay, and for constrained, what you're going to use is LSQ_lin. This is the function name. Okay, so if you want to do this, first is we have to add a constraint, right? So constraint could be in various form. Okay, so we could have a constraint saying that our it could be intercept could be 0.82 or greater than a equal to or equality like that, right? And we can solve this again, right? So we have to use optimization toolbox here, and this is how you set that problem. Okay, so you can use options, right? And you can set the solver that you want to use, algorithm, right? And then algorithm you specify active set like that. Okay, once you do that, okay, let me show it to you. Okay, and then we check that. You'll see, let me make this plot outside so that I can zoom it. Okay, so once I open this plot outside, okay, so there are two curves here basically. So if I zoom it in this part, so you see there is a red color graph and there is a yellow colored graph. Okay, so what this tells you is that one is from unconstrained fitting and the other is from constrained fitting. Okay, so there is a slight difference in that, okay, which you can easily see. And this is just to demonstrate you that you can also use these kind of techniques where you can actually constrain it and see the difference between that. And if you want to see the fit, you can plot it on top of it. Right? So this is what we covered here, okay, for this statement. Okay, and how did we solve it? We solved it like this. Okay, so if we just take a look at the problem type itself, right, little more closely, the equation that we are fitting, we see that the equation is in fact linear in our decision variables and can be represented in a matrix form, right? In the bottom left corner of the slide, you can see the results of plugging my data into the this linear system. Okay, we can see that we have two unknowns, C1 and C2, and 6 equations. Okay, so this is overdetermined system. This is also an overdetermined system. So how can we find that C1 and C2? That is what we did. Right? So you can directly say divide the left part with the middle matrix, and you'll get C1 and C2. That's how, because as MATLAB is working on matrices and all the variables, right? So matrix works on matrices itself. So you can directly say A by B. Okay, so it will calculate the C. Okay, so well, instead of trying to solve this linear system exactly, how about we trying to minimize the sum of squared terms to close to 0? That also is, so you should recognize this is as a least squares problem. So this is a least squares problem, and is this often approach used for curve fitting problems? Is very often used. So I'll also introduce you to the L2 norm notation, just so that you are also familiar with it and relative to optimization also. Okay. So after we finish this, we can come to the other part, which is nonlinear optimization. And this is so I'm trying to increase the complexity. So take some simpler problem, show you how you use MATLAB for this, and take a another complex step and show you some more detailed demonstration of, let's say, nonlinear optimization. Okay, so in this example, a nonlinear optimization, we would like to minimize the function shown here. Okay, so if you see that function, it is actually a nonlinear function. Okay, so there are nonlinear terms in this equation. So we'll be using the fmincon in MATLAB. So there is a very popular solver called fmincon. Okay, so which is an optimization solver for nonlinear system. Okay, so this is, since this is a two variable function that can be evaluated quickly, we can create a plot of it in MATLAB, right? Like this. So these are two variables where I can directly create a plot, right? We'll use this visualization to understand how the optimization solver works, right? So, but in most real world problems, what will happen is there might be more variables than this. So you will not be able to visualize it. Let's say if you have 10 variables, how would you visualize that onto a plot, right? So let's see that also. Okay. Okay. So let's open this example here. Okay. So what I'll do is set this objective functions here first. Okay. So to do that, what I'll do is create this function, whatever you saw in the PPT. Okay. So I'll set this up, create this using our objective function creator. So you can say at the rate x log of that equation. Okay. So I'll say run this. So one object function is created in your workspace. So within your workspace, you'll get this objective function. Okay. So that will basically tell you that that objective function contains the following function inside. Okay. So if I go inside, you can also see that. Okay. Right. Okay. Now, next thing to do is we create a mesh grid, right? So we have to plot it. So as you can understand, this is a two variable system. We cannot directly say vary x from x1 to x2, y from y1 to y2, and calculate z. Right? So we can directly say a mesh grid. So mesh grid will generate x, y data for us to give it to that system and plot it. Okay. So what we'll do is we'll just run this and see that particular plot. Right. So what mesh grid has done is mesh grid has created these x and y so that I can get z. Okay, so it has created lots of plots, lots of options. Okay, so if you see, if I open this workspace here, right? So you see many values of x and y. Okay, so you see here, so there are 51 into 51x, 51 into 51y, and accordingly 51 into 51z, right? And that is what you see in this graph. Okay, so this graph here is the representation of that function, nonlinear function. Okay. So with MATLAB, the benefit is you can also visualize it, understand it. It's a live plot. So I can click on this 3D rotate and I can rotate this plot also here. Okay. So if you see from a visual inspection, yeah.
Sir, you are going so fast, sir.
Okay. So you can just let me know if I'm going too fast. Okay.
Because sir, we are not have time to write the script. Immediately you have turned towards the nonlinear section.
Sure. So let me know if you want to write it. Okay.
Yes, sir. We have to write it so that we can execute it.
Sure. So what you can do is you can write this. Okay.
Okay, sir. Thank you.
So yeah, let me know whenever I'm going too fast.
Okay, sir.
So you can write this objective function here like this. Okay, so at the rate x log 1 plus 3 into x bracket 2. Okay, this is x2, that is x1 here. Okay, power 3. So this is representing the same equation. Okay, so people who have MATLAB, they can actually try it. Right?
So there is no need to save the file.
Yeah, you can just directly run it.
So earlier we just make the files.
Right. Right, correct. You can do that approach also still. So all depends, like for example, let's say if you want to run it again and again, you can create it as a file also, and you can directly create it as a function also. Both options are there. So you can, if I don't write this here, I can call it from a file also. Yeah, I can call it. So you can use that still option. So people, you can also try to write this command also here, mesh grid. which is you have to specify that minus 2.5 to plus 2.5 is the range, and with the spacing of 0.1. Right. So when you do this, it will create data points between minus 2.5 to plus 2.5. Right. That is what you have to do. At the rate of x. So that defines function at the rate.
Name of the function.
It is a syntax. It is a syntax that there is a function with the variable x, like that.
For two variables, what?
Here only, like you have to write it like this: x2, x1, like that. So this is basically two variable.
Okay, you written that x2.
x2,
And x1.
x1. So here, if you see, this is x1, x2, like that. Right. So this is how you write it here also. Right. So you can have a variable x, but which has different variations, like x1, x2, like that.
If you want, you can write two variable x, y, z, something.
You can write that also.
At the rate of
x, y, z also. That you can also do. Right. So once you do that, you can actually go to the next step where you can evaluate this function. Okay. So what you have to do is first you have to initialize. So this command will create zeros, matrix of zeros in that size of x. Okay. And what I do in this loop is for I is equal to this, right? What you can do is iterate on x, right? So that you can get this objective function evaluated for all the options, right? So basically you will get a Z matrix which will contain the results of that function from those two variables, and then you can do a surf plot, right? So basically if you do the surf plot, you will be able to get a three-dimensional plot of x, y, and z.
There are some inbuilt tools also,
inbuilt tools also,
where you can just put the
objective function also, fmin con. Yeah.
And
Absolutely.
Constraint.
Absolutely. You can do that also.
If you can
Sure.
demonstrate that.
Sure. I can just show you. So if to do that, what you have to do is
Sometimes it's difficult to make the coding of that.
right.
So it is better to use the inbuilt.
So what you can do is you can use directly here Optim tool. Okay. When you do this Optim tool, right? There also you could actually do this same.
Yeah.
In
What are
the
the difference between that?
it is just same. I mean, you are trying to access this through a user interface.
Yeah.
So here you can specify which solver, objective function. You can write the same here also. So even you can copy this objective function here, right, and write it here also. All right. You can copy paste it like this also.
Yeah, okay.
Yeah. So what this will do is instead of writing,
Interior point.
yeah.
Algorithm you had taken.
Yeah, you can change this. So what you can do is instead of fmin-con, you can use different types of algorithms like constrained, unconstrained, min-max, genetic algorithm, or the earlier one that we showed, LSQ curve fit, LSQ lin, right? Curve fitting, nonlinear curve fitting, constrained linear least squares, right? So all these options are there. So as you change it, let's say if I change it to nonlinear least squares, let's say, or LSQ lin constraint.
I think nonlinear, unconstrained nonlinear.
Yeah. Unconstrained nonlinear should be there, right? So what we can do is, as you change this, so this user interface will change. So sometimes people do it like this also. If it is just they want to teach it, let's say.
Please demonstrate this.
Yeah.
The same problem with this.
Yeah. Same also you can do it, right? So I'll take it at the end once we complete this flow. Then we'll show it also this. Okay. Now let me close this. Okay. Because most of the time what I've seen is all the researchers, they use more MATLAB because it is more flexible to modify your algorithm and trust it. For example, here I can actually create this for loop, okay, and see the plot. But there you will not be able to see visualize the plot in the optimal tool. So Optim tool is very specific. Let's say it's like a calculator, handy calculator. You can just plug in something and see what comes out. Right? But MATLAB will give you full flexibility to try out all the options. Let's say this surf you cannot do normally typically. Okay. So once you are able to get this figure, which this one is something that you cannot directly easily get with Optim tool. So you can directly write a MATLAB code here. So once you're able to do this, to rotate, you can actually click on this icon here. Okay, so there is a 3D rotate icon here. Okay, once you click on this, you'll be able to rotate it. Okay, so looking at it visually, you can even make a very good guess that this function is minimum here somewhere. Okay, so what you can do is you can even click at this point. So if you take a look at this cursor here, so I can click on this cursor link, this link, you can click here. So this will give you option to select a point. So if I select this point, okay, this will also give me what is the values here, okay, or somewhere here, okay, or this point. Okay, so what are the values? So I can easily click on this and say that this particular point is x 1.6, y 2.5, and z is the minimum value is this. Right? But you are not sure whether this is the minimum, real minimum. Right? It could be just a graph. If we plot over, more a -10 to +10, it could reveal something else. Right? So this is just a visual inspection. Right? So what we do is next, we keep this open here. Okay. Okay, so let's delete this point. Okay, I'll keep this graph here open. We have already plotted this. Now we are going to create constraints. Okay, lower bounds and upper bounds. Right. So you can easily say my lower bounds is from -2.5, okay, to upper bounds to 2.5. So this is for x1 and x2 both. So all lower bounds of x1 in here, all upper bounds of x2 in here. Okay. So you can easily say LB is equal to -2.5, -2.5, upper bound is equal to 2.5, 2.5 in a matrix form. Okay. Once you have done that, okay, then you are ready to for setting the optimization option. Right. So this is something that you do even from the Optim tool that I open. You can, that is what exactly the Optim tool does. Right. So when you select the solver, whatever the display settings, iteration that you want, right? What are your output functions? So this is my output functions, right? You can do that through a user interface also, and you can do it through MATLAB also, right? But here you get more flexibility, as I said earlier. You can play with it more. Okay, so you can set these options before, and then you start with fmin_con as a solver. Right? So you can use this as a solver. Type the objective function here, which we have already declared, and you can say this is your start point. You can leave this blank because these are attributes you have to pass, but you don't need here, so you just leave it, and just type in here lower bound, upper bound, and the options that we want to pass to this solver. Right? So once we execute this, it will start running that. Okay. So people on the phone, I mean, you can try this. I'll keep this open. Okay, and I'll also try to run this. Okay, so what you will see is this is my command window here. Okay, so when I run this, okay, this section, so I've set the upper bounds, lower bounds, and then when I run this, it will start creating optimization here. Okay, so what I have done is basically we have plotted this function. And we started with this as a starting point, and it went to this point location, which was the minimum for that range. Okay, for the range that we have given. Okay, so it has clearly showed that this will be our point here. Now this is a two-dimensional plot. Okay, so you can rotate it, but you will be able to see only 2D information here. Okay, so you can easily get this option here. So this will be a more engineered approach toward finding the minimum. Earlier we took a look at the minimum through visual inspection, but that's just a visual. Now to use min_con, this is how you start. So you start, and this is how the solver will converge to a point and give you the option. Okay. So once it has converged, you will get the final values also. Right? So we are able to find the local minimum that satisfies the constraints. Now, what's next actually? So if you see here, what we have done is we have evaluated all these options here. So you can actually take a zoom it at particular location and see what these points are like. Okay, let me open it. So we can take a look at here, let's say.
Excuse me, sir.
Yeah, yeah.
You are again going with the same page.
Okay. So let me know where you are.
So we are on the plotting the display option, output display option.
Output display option.
Here.
Okay, here.
Display output dot function FUNC COUNT.
Okay, here. Okay.
Yes.
Right. So I'll keep it here. Like, let's say I'll keep it to this point so that you can actually write it also. Okay. So so most of you people are using 15 B or some lower version or higher version. Anybody using any problem trying to solve this? Because if you might try to solve this in a lower version, you might face difficulty like below 2010 or something. Anything above that should be fine, because this is a very old function. Should work directly. Okay, so once you're able to do that, you can actually also see what in detail these points look like. So I can actually zoom it at a particular place and see what these points look like. Okay, how this optimization actually went. So if you see, initially it will take large step. Okay, so it will take a very large step so that you're able to actually make faster iterations. And once it goes into an area where the F count will go down, it will start to go in smaller steps. Okay, I'll show that in detail also in others also. So once it has done this, okay, what you can do is actually you don't have to write this also, because this is just what I have written. This is main important, this part. Okay, this is, I'm just doing this so that I can actually zoom it in the graph. You don't have to. I'm just for my demonstration only. You don't need this to in your optimization. Okay, once it is there, you can actually set the GCA limits also, just to zoom in. So this is you don't have to also write this also. I'll just explain you what this does. So this is basically controlling the figure. Actually, so if you see this figure, right? So this figure can also be controlled through MATLAB. Okay. So what you can control all the aspects of it. So how this figure, so I'm rotating it manually. Okay. Or if I want to zoom in, let's say this is how I want to zoom in. Okay. Now this is I'm doing it manually. If you want to do it through a program, you can also do it. And this is how you do it. So you say you just write GCA. There's a control handle for figures, and you say what is your X limit and what is your Y limit. So when I execute this, what you will see is that automatically in the figure, it will zoom it to that point. Okay, automatically. Right? That's how it will do. So you can, that is just a demonstration. Okay. Now, so this is, you don't have to write. Once you, if you have executed till here, people who are on the phone, if you have executed till here, then you can directly start from this option, which is what we are going to do is, so all these extra functions, evaluations can take a lot of time. Okay, so this example has two variables, x1 and x2. But if you are solving a problem that has 50 variables, that's 50 extra functions, evaluation that fmincon has to do each time, right? So there are actually two ways to do this, right? So one is supply the solver with these functions that calculate gradient and Hessian. Everybody's aware of this, or like something new, right? So this is particularly a different approach, right? So what you can do is you can actually calculate the gradient and the Hessians of the functions, basically like the deltas of this function, and you can supply that, so that will be faster, right? You can just note it down. You can actually look at it later on also, because if we do it, it will be too much time consuming. Okay. Other thing to do is parallel computing, right? So when you can actually even make the problem efficient or solve the problem in a different way, like using parallel computing. Like you have a lot of cores in your CPU or the GPU, you can actually parallelize that also. Okay. So what options is like say first to calculate the gradient and Hessian. In MATLAB also you can do it directly, right? So, and you can directly say you are already defined the options, right? So you can say options dot Hessian and options dot gradient on user supplied, and you can supply these functions directly. So if there are people who are not aware of this, you can actually look at it through Google later on. You can search it, but just think, keep this in back of your mind that this is also one possibility when you have a lot of functions. You can actually apply this gradient and Hessian technique and make 50 functions much faster, implemented over your optimization problem, right? And then you can again do that F-min solving. Once you do that also, okay. So I can just show it to you. You might not need to run this also, because main thing is till this level, okay. This is how you set that optimization and min-con, right? Once you are able to do this, you can directly start here and even do this also, okay, where you can supply the all the gradient and Hessian function, okay. So I'll just show it to you how this works, okay. So in times of running, if you see, okay, it's slightly different approach. If you see earlier graph, it went through here and this way. When we supply the gradient and Hessian, it will follow a different approach and will give you a better option. Okay, here in this case also. But here the noticeable difference is less because our functions are same, which is 2. But if functions increase, then you'll see a more noticeable difference also. Right. Even you can also this just I can also once we end this later on, I can share these functions. So so don't worry about the script also noting down. I'll share this script also later on. So it's something that is not you have to keep noting down. You can just focus on the whole idea, and I can send you this script also later on, so that you can try it, right, at your own time also. Okay, so you can sorry, there is also a method which is known as symbolic math method. Okay, so what this does is you can actually write expressions in a mathematical textual language. Okay, so what it means is you can actually write actually like x by 2 and like that. So this will help you to basically write long equations. So sometimes when you write equations in MATLAB, it might take a lot of effort, like for example here writing this function. Okay, so if we write this function here, it will be different. When we write it in symbolic math, it will be slightly different because it will be like 3 into 3 bracket like that. So it will be much shorter. Okay, but the difference will be pretty much same. Let me show it to you. Okay,
so there is any tool to convert the symbolic function into MATLAB function?
So what tool that we use is here. So I'll show it to you. We use a tool called MuPad here. So there is a MuPad notebook in apps. Okay. In apps. So if you have a version which is 2012 onwards version, you can use this MuPad tool and click here. Right. So it will come to this option here, which will say here you have to specify it like this: x is equal to x into sine of x, like that. Okay, and when you run this, it will create a syntax like this: x sine x, like that, symbolic syntax, and then you can actually solve this, right? So I'll not go into too much detail, but just as an idea, you can also use MuPad here, and I'll show it to you if you want. I'll take this after this session, because maybe if it is relevant to most of the people.
This is, you mentioned that sine x.
Yeah, x into sine x. Right, so this
will be the MATLAB function.
So you can directly use this. You can directly x sine x. Now.
So no.
Yeah.
Either I have to save this file or
you have to save this file. You can save this file also, and you can directly call MATLAB MuPad from MATLAB command also directly. Like here, I'll show it to you.
So can you show me how you insert that function into MATLAB?
Right. So that's what I mean. I don't know if everybody is will be relevant for. So we can park all these questions. So what?
That is the main difficulty with the MATLAB.
Okay.
When we write the program, every time we have error.
Mm-hmm.
due to you don't know how to MATLAB functions,
Okay.
commands.
Okay. So I could from MATLAB basically. So just to give you a direction to it, what you can do is in MATLAB, if you see, our documentation is very strong, right? And most of the users already know it. So we have a very strong MATLAB documentation. So what you can just do it directly say mu_pad, okay, from here, okay, and go to it, and you can directly say, let's see this symbolic math here, toolbox, and symbolic computations in MATLAB directly, you can say, okay. So once you do that, you can actually get a lot of examples here, okay. So I can take maybe one example just to give you an idea, okay, how this is done actually, okay. So if you see here, this is a numerical computation, let's say with high precision. So you can say, so this is how it is done using MATLAB. So you have to say symbolic, like sim command, okay. So I would say better you just go through this documentation first. That will give you a first high level understanding, because we can spend 2-3 hours only in mu_pad just to give you a flavor of it. So best idea is to go through the documentation first, and also if you are very new to it, you can just say directly getting started here. So on this page, if you have, so if you say this here, okay, and you go on this options, symbolic variables, expression, functions, and preferences, okay. So if you get here, it will go take an example step by step, and you will learn it on your own. Right. So this is just a pointer, so that you can keep this in mind. If you have, I can also share you my email ID. You can even shoot me an email about any specific advanced questions that you have. Right.
We can also add this MATLAB into older version.
In older version also it is there. So what you have to do is you have to type here. You can type here mu_pad like this. So if you type mu_pad, it will come as but depends like how much old version it is. If it is not showing in your apps, you can directly say mu_pad here, and it will open like this.
Yeah.
It's there, right? Yeah. So it is now in apps, but in old version you can do it like that also. Okay. So people on phone, I mean, you don't have to write it this particular. If you are able to solve till this option, I think that should be sufficient to give you an idea how to use this fmain_con as a solver, right? That was the whole idea. Next thing is, let me take you some more examples, right? I'll send you these files also, so don't worry about it. I'll find a way where all the people, I think you have already registered, all the emails IDs are there, so I can send these files to somebody centrally here in the institute, and they can forward you all these files, so that it is there for you to practice. Okay. Okay. So another type of nonlinear system. Okay, here. So taking this same approach and applying some application to it. Okay. So this is just an application here. Okay. It is also falls into that category of nonlinear constraints. Okay. So in this example, we'll model a gantry crane. Gantry crane is something that moves things from ships to offload to a harbor. Okay, so it will take something and move it here, just like a crane. Okay, but it will move like a swing. Okay, so things will hang on from the rope, and it will move, and it might swing also. Okay, so the idea is we want to move this cart such that the payload swings as little as possible. Okay, we want to move it, but we want the swing to be minimized. Okay, it should not swing too much. Okay, so the less payload swing better, since less swing means we less the payload immediately when it gets back to the dock. So if we start, it will start swinging, and you'll not be able to keep it down. In this example here. So what this will happen is it will come down. You'll come to this location, and it will start swinging like a pendulum, and you don't want that to happen. Right? How about you move this crane in such a trajectory that it comes here and there is no swing, right? That's also a good optimization problem. Okay, so let's see how you will actually solve this. Okay, let me start from there. Okay. Okay, so if you see the MATLAB file will pretty much look like that. So if you see all of my files, they have sections. Okay, so I create a lot of documentation and everything. So there are a lot of sections already here, right? So I have all this zipped file here that you will get it directly. So you can just focus on these areas. So because these files may be large and you might need a lot of time to just write these equations, right? So you just better what you can do is have a look at the example, and once I send these files to you, you can try it on your own also. That also you can do, because at times they can be too long to just type. Okay, now here what I'm going to do is set up some initial values, like I'm parameterizing it, like height of the crane, the payload, displacement, length of the first pulse, second pulse, like that. Okay, so pulse is how it moves. Okay, so let me show it to you. So what I'm going to do is basically solve it like an ODE, right? So I'm supplying certain information here and solving it and showing it to you here. Okay, so you'll get this solution and you can directly say plot, and you can even animate this. Okay, so let me show it to you. So this is your plot. Okay, so this is your ODE. So this is how it moves, and this is your acceleration. Okay, so this is your angle here, and this is acceleration here. So if you look at the plot, so first plot we have acceleration, and second plot we have angle here. Okay, now what we want to do is after it reaches the dock where it has to drop that payload, acceleration has to be like, angle has to be 0. This part has to be 0, and it is not being 0. Okay, even we can animate and see it. That may better give you an option, right? So this is how it works. Okay, so what is happening is it is coming to end, but it is oscillating. Okay, so let me show it to you again. Right, so this is on the bottom axis you have basically angle. Okay, so angle is still moving, while when it comes here, by the time angle should have been 0. Right, that is what we need. If you notice it, this dot here, when this dot touches here, it is already reached that position. It has to be 0 by that time. Okay, now how do you solve this kind of an optimization problem? Right, so again what you have to do is there are certain constraints, there are certain objective function here, right? So you have to define these constraints, right? So we define the following constraints. Let's say time constraints we can have. So we have time. I mean, we cannot have infinite time. It goes very slow, right? So if you say, if my crane the payload does not need to oscillate, you can directly say move it very slow. Move it very slow, it will not oscillate, right? But it will take too long. You don't even want that also. So we need to define time as a constraint. So our time constraint is also here, right? So we need to shift in pulses. So let's say there can be 3 pulses durations where you can move or accelerate, deaccelerate. Both options are there. So you say totally I will give you 50 seconds to do that. Right, in 50 seconds you can accelerate as fast as you can deaccelerate as fast as you can, and you can actually perform this maneuver. Right? So that is your constraint you have already defined. Right? And then again, as earlier, we solved the limit problem, minimization problem. We again set these options and use the fmin_con here again. Right? In a similar approach. The same approach applied to an application. Earlier it was just a mathematical function. Now it is applied to an application. Okay, of a gantry crane. So what we do is, if I run this as an example, it is going to start optimizing here. So you see it has taken certain iterations, and this is your f count. Okay, once this is done, we will be able to get the optimized solution. Okay, so it has found the local minima and constraint that was satisfied. Okay, so what I'll do is I can display the output from optimization. Okay, so let's see that also. So this is the display from the output. Okay, now this is our acceleration divided into three parts. Okay, so if you take a look at the acceleration, it starts with a positive acceleration, goes into a negative acceleration and then a zero acceleration. So there is a positive acceleration here in this part from here to here, okay, and there is a negative deceleration in this region, okay, from here to here. So what you do is, you using this acceleration, you will be able to achieve this kind of angle, okay. So it will swing, it will be controlled, and by the time it comes to that position, the swing would have been zero, right? It will do such a maneuver, okay. So if you see that after certain that same time, we are able to get zero acceleration here in an ideal condition, okay. So let's see and animate this again, right? Okay, so you can see that, right? So it starts with a swing, but it moves in such a way that it actually gives a zero angle after that time. Sorry, this is just plain MATLAB. Right. So how it is done is, this particular animation, it is just a plain, like you have to draw rectangle, lines, and circle, and you just change these positions. So all these positions are coming from this earlier graph. So you see this graph here. When I run this, okay. So basically, I have nothing but angle, right? So I have all the angles. So I use these angles to animate. So that is not doing solving, but I'm doing this and angle animation basically. So if you give this angle to that figure, it will start animating that basically. That's the one thing, right? It is just a plain figure. If you see here, this is also a figure, just a normal figure, okay. And the other graph is also just a plain normal figure. There is no difference to it. So this is also a plot, and this is also a plot, right? You can have simple plots in MATLAB just like this, like a data, or you can have animations also easily, right? Just like that also, right? So once you're able to visualize this, you can see that once you optimize that problem, you are able to get exactly what you needed, right? In an ideal situation. In a real situation, it could be wind and lot of things around, right? So there could be a different kind of situation, but in this situation, you are able to achieve that, right? Okay, right. So I'll close this. Okay. Now another thing is, you can also say you can just create a different type of problem. Okay. So what you can also do is, you can also run it through from a different starting point. Starting point could be different. So gradient based solvers like fmincon are designed to quickly find local minima. They are designed for that. However, if the problem is non-convex, okay, meaning it has multiple local minima, like it can have multiple valleys of like mountains, right? Then minimum found will be sensitive to the start point, right? So if there are multiple hills, and if you drop water, it may collect somewhere, but there might be a lower point also, right? So that is what it means, right? So you could have a local minimum somewhere else also, right? So let's try a different starting point. So if it converges to a different point, right? So if you start from somewhere else with some other initial condition, you may end up your results differently when you're using fmincon. Okay, that is also something to keep in mind. Okay, so what I'll do is run this. Okay, and you'll see this automation start here. Okay, so once it is started, we'll run with even multiple starting points also. So what we see is that we get certain conditions here, right? So with different start points, you'll get different time. How much it'll time to stop, right? So you see that it could be a problem which has multiple minimums, right? So this solution may not be the final optimized solution. You can have even better solutions because it has other local minimas also, right? So what you do is, once you want to do this, okay, you can use parallel computing. Okay, so you can actually use parallel computing to speed up your problems. Okay, so when you type power pool 2, this you can note it down. So what happens is, power pool will help you start parallel computing, and your program remains the same. So there is no change in the programming style. Okay, you just have to enable this. So when you say par pool bracket 2, that means two cores will be used from your PC, and they'll be used to simultaneously speed up your MATLAB. Okay, and how it works is basically problem remains the same. I'll just start it and show it to you here. Okay, so I'll go to this command window here. Okay, and run this. Okay, so when I run this par pool, okay, let me show it to you. Only I run this command. So when I run this par pool, you'll see the starting par pool. Okay, and in your MATLAB, if I open, okay, here, what you will see is that you will get actually 3 MATLAB here. Okay, so what does that mean is basically these 2 MATLAB are basically workers, right? And this is the main MATLAB here. Okay. So whatever you now do will be amplified by 2 times speed up, basically. So these 2 workers will also do it. Okay. So what I can do is next run. Then you run your program as it is, right? And then you can run it and see what happens. Right? So if I start running, you will be able to execute this and get resolution faster. Right? So parallel computing is very useful in getting these simulations done faster. Right? Otherwise, on your PC, it might take a lot of time. Okay. So what we are going to do is, it is also 11:30. So just to be on time, what we'll do is we'll take a break here, right? And then we will handle these 2 points in the next after the break. So we have done till here. We will use these 2 to basically in the next session, and we'll also take question answer. Right. Basically, this will take less time. Then we'll spend a lot of questions like on MuPad and other things that we covered. So we can even spend some more times on those aspects also. So let's take a break. I think it's a 30-minute break or 15 minutes break. 15 minutes break. So it's a 15-minute break. We'll be back again by 11:45, 46. Sure.
Excuse me, sir. Hello.
Yeah. Hello. Yeah. We can hear you.
Sir, this kind of documentation is available in 2015 version or 2012 also. It also included.
It is all this documentation is a part of MATLAB by default. So what
sir,
you
when
can,
you had opened this on the help file,
yeah.
you selected the option, documentation option, then there are certain M files that are available in your screen. But in case of 2012, it is not available.
Right. So which you are using version 2012?
Yes, sir.
Okay. So because of that, I think you might be able to not see those files, because what we have done is we actually improved a lot of things from 2012, yeah, to 2015. So current release is actually 2016B.
Yes, sir. I had
Yeah.
checked that.
Right.
But
So,
sir, how can we access this? Is it available online on MATLAB Central or
so yeah.
MATLAB Central?
So yeah, if you're a user, if you're a licensed user of MATLAB, you can
Yes, sir.
actually access the documentation online also, like the one you see here. So you can actually click on, you can go to MATLAB.
Mathworks.com. Okay.
Yeah, mathworks.com, and it will actually open documentation. You can actually search here. So you can even search here like MuPad, and you can say I want to search in documentation, and
Okay,
say run. So it will actually just be like how you open a help document in MATLAB on your local PC. You can actually do that online also,
Okay, sir.
and
Sir,
you
if
can
we,
do
if
those.
we do
Yeah.
not have any license version or we are trial version, we have trial version, then we can access that.
So some things it allows you to access online. Some toolboxes it may not, but I think yeah, MuPad it allows to access online. Yeah.
Okay, sir. Sir, can you share the scripts with us so that we can try in our
I
after the
Yes,
break?
yes. So what the idea is, I have all these files here
Okay, sir.
in MATLAB here. Let me show it to you. So what I'm going to give it to you is these all files. Okay, so I basically these files.
Yes,
Uh,
sir.
I can give it to everybody here who attended this training. So you
Okay,
can
sir.
actually try all these options: least
Yes, sir.
squares, nonlinear example, gantry crane, traveling salesman, multi-start.
Yes, sir. Because
Uh,
all the things which you had mentioned is quite interesting to for the
right.
biological students. We can
Sure,
apply
sure.
those things.
So I can send it to one of the person here, and I think your email ID will be there with institute.
Yes, sir. It is
So they will
available.
send it to you. I will give them this zip file.
Actually, sir, if we got it today so that we can practice that, because after the session we also become lean and
Yeah, yeah, yeah.
we are not able to do that.
I,
Right now
I
we
can
have time.
I can do it right away if somebody who is the center point to send files
Sir, so
after
which kind
after
of
break.
thing we have to do so that we can access this?
Sure. After break, we'll do that. After
Okay,
break,
sir.
you
Okay,
know,
thank
after
you, sir.
break, I'll give it to. I think local person is there, and they will give it to you.
Okay, thank you, sir.
No problem.
Thank you.
I'll, Start. Okay. So welcome back after the tea break. So now we'll spend more time into some more mixed
Excuse me, sir.
integer programming. Yes.
Sir,
Yeah, one
I had
question.
mailed you from Merit, MIT Merit.
Yeah. Tell me. Tell me.
So I had mailed you about the script. Yeah, I had given you my email ID
Sure.
for sending the scripts.
Okay. Yeah. We have already made the package and given it to the central person here, and the mail is also sent.
Okay, sir. Thank you, sir.
Okay, so the mail will reach you in 10-15 minutes.
Okay, thank you, sir.
Okay. Yeah. And okay, so what we'll do is we'll actually go to two kinds of problems. Okay. Basically, first is mixed integer. What this problem type is, basically in many scenarios, in a real world scenarios, what happens is sometimes your functions may not be continuous. They can be discrete functions also. Something like let's say number of cars, the production quantity, number of stocks, something like that, right? Or you could have decisions also, like binary decisions, like on, off, buy, don't buy, right? So when you work with these kind of problems, they are known as mixed integer problem. So it's a mix basically of continuous and integer functions also, and they are very typical all around us, right? So let's say, for example, whether if you're working in electrical system, right, you want to see you want to turn on the motor or turn off the motor, right? Like that kind of parameter, right? So mixed integer linear programming gives us a way to solve linear optimization problems with the constraints that specify the certain variables must come out to be integers, right? So you can even output can be integers also. Both options are there. So more formally, we have linear objective functions subject to linear inequality and equality constraints and bounds, right? Then we also have an additional constraint where we tell the solver which variable should come out as an integer. That also you can even tell to the solver, right? So it looks like something like this. Okay. So if you see, these are the continuous and integer variables, and you have linear objective and constraints like that, and you have to minimize, let's say, this. Okay. So applying this same technique to a very common problem. Applying this to a very common problem. Okay. So what we have is a traveling salesman problem. Okay. So in this, let's take a look at an example where mixed integer linear programming problem is used. Right. So this is a traveling salesman problem, very popular, but turns out to be very difficult to solve in practice. Right. So this problem is what is the shortest path that visits all of the stops that a salesman needs to visit. Right. In other words, given a set of points, right, what is the shortest possible path that goes through all of those points, right? Like, for example, we have these points. Now, what is the shortest path from going from this point to this point, let's say, right? So you can go like this, you can go like this, or like this, right? So there are various paths. Okay. So what is that shortest possible path? The number of possible solutions to this problem grows exponentially as the number of stops increase. So as you increase, it will go exponential. So it quickly becomes impossible to evaluate all possible routes to find the shortest, basically that path. Right. So it will, as the number of points increase, it will become too large problem to just find that manually also, through iterative also. Okay, so let's take a look at how we can formulate this as an optimization problem, right? So the first thing we'll do is to calculate the distance of all different points. That's what we are going to do, right? The next thing we'll do is to assign a binary variable to each of these segments. So that is how we are introducing integer part here, right? So what we will going to do is we will calculate the distance of each thing and assign a binary variable to it. Okay. So a 0 means that we are not taking that segment as a part of a trip. 1 means that we will be taking that segment, like here if it is shown, right? So if you see, so this is just a general connection. Now here, if we say this distance, we say 0. We say we are not going to take this decision into account. We will take only once, right? Because sometimes the 0 can be too large, so they don't need to be evaluated. Okay, so we'll need to add constraint that specify that all of our segments should be line up so that we have one continuous strip that goes through all of those points, right? And let's jump into MATLAB and see how it is done. Okay, so this again, as I said, it'll be slightly large MATLAB file here. So what I would request you to is to use that program that you already have. It's already sent, so you'll be receiving it. You can actually start this from this folder. Okay, so you'll have all these files with you. Okay, so this problem is under this folder. Okay, so traveling salesman problem. Okay, this is inside this folder. Okay, now so starting this, what we are going to do is let's make it more visual. Okay, this problem. Okay, by visual we mean let's make it a real world problem. Okay, so if we look at this, it is just plain dots only. Why not make it like a real traveling salesman problem? Okay, so this also demonstrates what new MATLAB can do for your projects and for your learning. I mean, when you want to work on certain projects and show some graphical results, what you can do actually achieve with that. Okay, now what we are trying to do is we have a mat file which has all the different office locations, let's say, okay, where we want to visit. So in a mat file there is a latitude and longitude, it is already stored. There is also something known as web map. Okay, web map allows you to basically draw a live map just like Google Maps, right? It is zoomable. You can actually point and see where these cities are. Okay, so we are going to use web map to draw those markers. Okay, so what we are going to do is we are going to create water markers, okay, on all these latitudes and longitudes. Okay, and officer's name can be our feature and the address. Okay, and we are going to draw this logo, which is basically nothing but MATLAB logo. You can put any picture there. Okay, and we'll say zoom it to 2 level. Okay, so once we run this part of the code, okay, you'll see what will happen. Okay, so when I run it, it is going to open web view, web map display. Okay, and you will be able to get this option here. Okay, now this is web view, so this is just like Google Maps, so I can pan it, zoom it, right? So you see here, so what I have is all these markers, right? So if you see in the world map, we have created markers. Okay, web map. So there is Los Angeles, Chicago, New York, some places in Europe, 3 places in India, and some places in Southeast Asia, right? Now if somebody asks you that you have to go from Los Angeles to Tokyo, visiting all these, right, what should be your shortest path? Which path should you choose, right? Should you go here? And so one thing is also very clear here, right? What clarity we have is that, okay, these are from the same continent, right? These are also from the same continent, these are also from the same continent. So basically when you leave this continent, you will go once only here and do whatever here and come back here and do whatever here. Okay, that is how you can see it very clearly, right? But inside this, let's say here, like here, how do you go it? I mean, would you go here first and then take this route and like that? You cannot easily make it out, right? So that is what this problem is all about. Okay, so this thing is just to show you that you can also use these kind of applications where you can actually draw data over a map, lay it over a map. Okay, so let's see how many possible paths are there. Okay, so if I do this, okay, you will just be surprised. Okay, so this is the number, the possible path, right? So it is 4 into 10 to the power 26 possible paths, right? So that is really big number, right? just a permutation and combination. So evaluating all those will take a lot of time. Just evaluating one by one will take too much time because the values are very high. Okay. Now what we have done is, so just to cut down how to improve this problem, we are using mixed integer problem. Okay. So we are formulating this problem into a integer linear programming as follows, right? So what we do is we are doing something like we generate all possible trips, right, and distinct pair of stops. Right? Calculate the distance of each trip. The cost function to minimize this is the sum of the trip distance for each trip in the tour. Right? The decision variable are binary, as we said, that what we are going to take will be treated as 1, and what we are not going to trip on that tour will be treated as 0. To ensure that our tour includes every stop, include linear constraint also, that each stop is only exactly 2 trips. So you can enter and exit a place, but you cannot enter it back like that also. That cannot be a constraint. That can be a constraint. Okay. So now what we are going to do is we'll calculate distances between points. So because there are 27 stops, so we have in this map, okay, so we have 27 stops here. Okay, so we need to stop at 27 places. Now there are 351 trips, meaning 351 binary variables. So we say ones and zeros, just like we did it in the slide here. So we specify ones and zeros, right? Where we can go, where we don't want to go, like that. Okay, and generate all trips, meaning all pairs of stops. Okay, let's see that. Okay, okay. Equality constraints we can have, and then okay, and see it. Okay. All right. Okay. So let's see that. Okay, it's still coming up. Okay. Now what we want to do is once we set that bounds. Okay. So let me come here and show what I did. So we can even set equality constraints also. Right. So since this problem has 2 types of equality, right? The first one that enforces that there has to be 27 trips in total, right? So 27 places to go, 27 trips, right? Second is each stop has to be like one in and one out. You cannot have multiple in and out, right? That is how you distribute these constraints. Now, second type of equality will be there needs to be 2 trips each at each stop. So that is how you define it also, right? That it cannot be have more than 2 trips in one city, right? And then you have binary bounds, right? So binary bounds you can put like all decision variables are binary. Now it can have 0 or 1. That is it, right? And then we basically go using the same approach, and we solve this problem using interior linear programming. Okay. So as you see, you can also do this with the Optim tool. Right, you can also call it through like interior linear programming also. Right. So what I do is I run this part, okay, and you'll get an answer and visualize this problem also. Okay. So you see here now. Okay. So what we have got here is so if you see these are just local travels, right? Right. So if you see. What it means is like sub tour constraints. Okay, so what you see on the map is like several sub tours, right? So the constraints specified so far do not prevent these sub tours from happening. In order to prevent any possible sub tour, you need to incredibly large number of inequality constraints. Okay, so what is happening is so you are saying that it has to be short, right? You're not saying that it has to go from one continent to another. So it is taking every part individually, right? So if you see, this is kind of like one solution. I mean, every state is visited, every city is visited once, right? 27 times. There is single in, single out, and this is also true. Right? You can even go from here to here also, but that is not coming up here, right? So we need to put that also as an equality, that you have to go from here, this continent to the other continent. That is also an equality, right? So to do that, what you get, because you cannot add, as you see, I mean, I've documented everything. So what you can do is add all the subtour constraints, right? They'll take too much time, right? So we take an iterative approach. So detect the subtours in the current solution and add inequality constraint to prevent those particular subtours from happening. So by doing this, we'll find fewer iterations basically, right? And eliminate tours with inequality constraint. So how this works is basically if you have 5 points in a subtour, then you have 5 lines connecting those points to connect the subtour and eliminate this subtour by implementing that inequality. That is what you have to do, right? So what you have to do is you can say tours, detect subtours, and you say number of tours and restrict it. Right? So if I do this, run this part here, you'll see here number of subtours are 6. And that you can also visualize here also, right? So there is 1, 2, 3, 4, and 5, and 6, right? So this 6 it constitutes, right? Now what happens is, okay, you can actually go to this inequality and add it to eliminate those subtours. Okay, once we run this again, okay, this optimization again with those chosen, will get a better solution basically. Okay, so this is just eliminating those subtours. Okay, this part here. So once you get this file, you'll also be able to see that this part here, what it does is basically it is taking all those options, tours, and manipulating the functions in such that those 2 subtours get eliminated. Right. So let's see that in action, like that. Okay, so here what you see is, now if you see here, so it's a continuous, this line is coming from this part here, okay, this line. So you see is that this is the shortest path here now, if you eliminate those subtours. So you can go from Los Angeles to Chicago, New York, UK, and then this is how you come, right, and this is how you go. And then you can go to New Delhi, yes, Pune, Bangalore, right? And then you go here, and then you go to Australia, right? So this is how you can convert that problem into to remove those subtours also, right? So this is a slightly complex problem. Just wanted to bring it here so that you can also get an idea about problems that involve integers also, right? And this complex problem is a very good example to show how an optimization actually problem can be solved. Any questions? Okay. Now, once we have got this, we can even get the solution quality also. So solution quality, what it means is that how good is your optimization basically. Right. So if I show it to you here, okay, right. So when you say output, just this and answer, you'll see that there are a lot of parameters that are shown here: relative gap, absolute gap, number of feasible points, nodes, message, all that. Right. Important is these aspects like 0. Right. So what will happen is the solution gap here, the gap between internally calculated upper and lower bounds, right? Solution objective function, right? Reported output structure is 0, right? So that is why you see this solution is optimal, like that. Okay, so you can even check this output also to see whether this output is the best optimized solution or not, the feasible. Okay. Apart from that, one more thing is that I have covered all these aspects from MATLAB point of view, right? So this is an optimization that can also be used from Symbolic also. Okay, so to do that is so you can apply it, let's say, to an electrical engineering problem, or let's say a signal processing problem, antenna design problem. So various aspects that you can apply this to, right, for an application point of view. So I'll take one more example where I'll show this as a part of electrical, let's say, optimization design problem, right? Because many of you would be engineers actually working in the area of let's say electrical engineering and would like to use optimization for your electrical optimization, right? Because at times what is happening is, yeah, these problems are very good, but they are more mathematical in nature, right? They need to be applied to our own domain area, then it can be really useful. Okay, so to do that is I'll open Simulink. Okay, so what the idea will be, let me first show it to you, that problem. Okay, let me open one example model. Okay, give it to me. Okay, okay, so it is basically an example of this DC motor driven from an H bridge, let's say controller, here voltage controller, right? So what this problem is all about, so if you see, this is made in Simulink. You could actually use Simscape to make this, right? So how it is made is, all these blocks are available as a part of Simscape library. They're part of Simscape library, which you can find here. Okay, so if you go to Simscape, okay, and you say foundation library, you will see all these electrical, hydraulic, magnetic, mechanical, all these libraries, which is you can directly use here. Right? So I've used inductor, resistor, capacitor from here. So I can make nothing but the schematic of an DC motor. Right? So these are all electrical parameters. On this side, you have mechanical parameter like inertia, damper, converter from electrical to mechanical. Right. Similarly, in my H bridge, I have these switching devices. Okay, so these are nothing but switches. So I can control them from a controller, and this will give basically positive polarity or negative polarity to this motor, and it will run. Okay. Now, what is the problem all about? Okay, so basically, I'm giving an input voltage. Right. So there is an input voltage. Let me simulate it for 4 seconds. Okay. So I'm going to give an input voltage, and I'm going to get the shaft velocity. So how the motor is running. Okay. So this is my input voltage. Okay. So that's my input voltage. So basically it is just like switching. Right. So these are like nothing but PWMs. So these PWMs are being created, and accordingly you will get a voltage here. Okay. And this is the shaft velocity. Okay. I think just let me make it more bold, all these lines. Okay. Let's make this thick, and even make the other ones thick. Okay. Line measure data. Okay. So now what you see on this this particular graph is there are two graphs from this shaft speed. So this is the motor speed. Now there is a blue graph here, and there is a yellow graph here. Okay, so this blue graph is what we get in actual real life motor. So this is an experimental data, and this yellow color data is what you are getting from this simulation that you see on the screen. Right. So if you see here, okay. So people, you have used MATLAB. So this is the shaft velocity scope, right? It has two parameters, this one and this one. So this parameter is nothing but this yellow line, and this parameter is nothing but the blue line. Okay. So what you see is this blue line is coming for measured data. So this is the measured data that you see here. Okay. Now both the plots are plotted on this same scope, so that you get an idea that your motor is running, but the real motor runs differently, right? And the simulated motor runs with a very big difference, right? It should match with the actual motor, right? And what could be the reason why this motor is not running as a real motor is, if you see, the behavior is pretty much similar. The yellow and blue behavior is pretty much similar, but they are amplitudes don't match, and their timings are also slightly off, right? So how this this brings us to the optimization problem. Yeah, I'll show it to you. Okay. So here the problem is that when you run a real motor, you'll get this result when you switch on and off motor, right? So this, we are giving basically a kind of a pulse to a motor that, okay, switch on and switch off. So it will run with certain speed. When you reverse the polarity, it will run opposite direction. Again you run it in opposite direction, again you run it in opposite direction. So this is the velocity, the RPM, let's say, you can say. So this is your angular speed. Once you are able to get this angular speed from the real, you want to simulate that basically in a simulation environment, let's say using Symbolic or MATLAB, right? So we are using Symbolic, and when we model this, so we are getting this yellow curve here. Okay, so that is our actual simulation result, and this is not matching with this range. So even amplitude is not correct. So this is giving us 1.2, and this is only at 0.3 or something. So their amplitudes don't match. So basically simulation is not correct, right? But the trend is correct. If you see, it will switch on, but it will go to 0.3 only. It will also go reverse, but only to -0.3. So the trend is right, but the values don't match. So how would you make that happen basically? So the reasons for this to happen is because your parameters of these components may not be correct. Okay, so resistance, how do you calculate the resistance of a motor? Inductance, how do you measure inductance of a motor, let's say, right? Then inertia, how do you measure that? So sometimes you may get this from the data sheet, but sometimes you may not also, because they might not share that data with you. So because of that, you can actually face these problems where you model something, simulate something, but you don't match what you are looking for. Okay, so to address that, you can actually use optimization to find out all these components parameters to match exactly like that. Okay, how do you go about it is, so you create these parameters. So instead of this resistance, instead of giving a value, you just parameterize it. You say DC motor underscore R. Okay, so that's a resistance parameter. Then you have inductance, so DC motor underscore L. So instead of defining it here, you just parameterize it. Okay, once you have parameterized it, right, what you can do is you can go to this main block diagram, and let me zoom it. There is a tool here, so you can go to analysis and you say parameter estimation, right? So this parameter estimation uses optimization toolbox at the back and gives you the same capability to apply the optimization to this problem also, right? So there is one optimization tool applied for various applications, right? So let's see how it is applied here, right? It is very easy to do it. So if you see, if you traditionally do it, you have to do hit and trial. There are 5 variables. You have to do a lot of hit and trial, and probably you might not get the right answer also, right? So best way is to use optimization. And how do you use optimization within Symbolic? Is using parameter estimation. Okay, so what you do is click on this parameter estimation. Okay, this will open a user interface which allows you to basically create a new experiment, select the parameters that you want to basically optimize, okay, and see the results experiment. Okay, so what I can do is, let's say select a new experiment. Okay, now here if you see, it is asking you to select output, input, and initial states if any, and parameters. Okay, so you can say I can select from here, so I can go and select a signal also. It is already selected. Okay, so this is input voltage and this is the output from that motor, already selected. Because we have only one input and one output, that is already done, right? If you had multiple, it would show up here. Okay, okay, once it is done, you can select parameters also here also. Okay, so when you see select parameters, it is giving you option. So you can select all these options here. Okay. So how many? There are totally 5 variables here. So DC motor B, J, K, L, R, right? And when you select, you say OK, right? And then you say OK here. Okay. Once you have done that, all your parameters will also come up here also. Okay. Okay. If it doesn't come, then you can even select it from here also. Select parameters. Select here. Okay. And then say OK. Okay. And then fine. Okay. Once you have selected, so you'll get all these parameters, right? And you can double click on them, and you can even say they are estimated and their boundary also, right? So let me try to show you how it is done here. So this is the current value of this parameter, but you can also give some boundary range where this parameter has to be found. So let's say the DC motor underscore B. So like say resistance. Let's say this example resistance here. So it is showing here minimum is minus infinity. So you say I don't want minimum to be minus infinity. I want minimum to be 1 ohm. Let's say. So you say minimum is 1 ohm because resistance cannot be negative, and even it cannot be infinity. So you say 1 to 100 like that. Find me the resistance in that range. Same with inductance. You can even say from 1 to 100, right? And these constraints are important because certain constraints you might get optimization, but if it gives saying the resistance has to be 0 or negative, it does not make sense, right? As we saw in earlier problem statements also, right? So it is very important that you define these constraints correctly, right? Once you get this, because optimization, if you leave it unconstrained, it can give you a solution which may not be feasible. Okay, so what you have to do is first set all these options. Okay, once you have set this, you're fine. Okay, then what you have to do is go to experiment, right? And you can say, you can even import this data. Now what you have to do is, if you see here, so we want to match this blue color line. Okay, so our simulation is giving this option yellow, and we would like to match to this, right? So what we have to do is, this is going to be our objective, okay, function, and this is our simulation. So we have to take the difference and minimize that error, right? It is just kind of minimization problem. Okay, but using parameter estimation, it is much easier to operate fmincon here also. Okay, so how it is done is, so let me zoom it here. Okay, so under the experimentation, you can actually say import data, okay, into this. Okay, so when you say this, you can actually say import data, import signal, right? So that is what it says, and it is there for both output and input both, because what you do in simulation is the same that you do in real experiment also. You give a signal to a motor in real life, measure it, and collect the data, right? And in simulation also you are doing the same thing, right? So whatever you collect, you will click on this option. So suppose you have collected the output speed data, so you click on this and select whichever file that you have stored. It could be Excel file, text file, something like that, right? So you can import it from here, and again you can import it for input also. Okay, so once you import it, let me show it to you how it looks like. Okay, let me show it to you. Okay, so once you have imported it, right, so you can actually plot the model response. Okay, let me plot it from here. Plot measured, let's say. Okay, So what we want to do is whatever data that we have imported, we want to see how it looks. Okay. Now this is how the data looks. So this is what we have imported. So in experiment, we gave some pulses to this motor, and this is how the motor moved. Right. We should be able to get this. So if we can even plot our simulation also, both plot measured and simulated. So it will run the model at the back and simulate and show the results here. Now you can very clearly see that the simulation is on the red line and the measured is on the blue line, and they don't match. Right? We have all the parameters set. Right? We have the objective, we have the current simulation result, and our problem is fully ready to be optimized. Okay. Now what we are going to do is we want to add some plot. So while the simulation runs, you can actually add some certain plots like parameter trajectory. Okay. So what does this do is left right. Let me put it like this. So what it is going to do is it is going to perform now optimization now. These are the parameters. It will be shown here how they are changed at every iteration. So this x-axis is iteration, and this is basically your parameters. So how they will be changed as each iteration, and you'll see how this data matches with the real signal from the experiment. Okay. So let's go and run this. So we are directly fully ready. Okay. So you can here choose a cost function. Okay. So you can say sum squared error, and you say estimate. So this here will start the optimization at the background. Okay, I can minimize this, and so that you just focus on this part here. So at the back end, if you see, the model is running again and again, and once we get this first iteration, you will see this results here updated. As the iterations go on, right, you will see the change in the simulation result. Right. So this way it will be, so you see the first iteration came, and the measured and the simulated results, they came very close to each other, but still their shape is not correct. Right. Now as you'll see this, as the iterations move on, you'll get more closer and more closer to actual experimental result. Right. So your simulation will match exactly what your motor should give in real life. Okay, so this is the application of the same optimization into a very specific engineering problem. Okay, specifically for electrical engineering. Same problem again can be applied to different domains also. It could be mechanical, it could be hydraulics, it could be, let's say, biotechnology, anything. Right? Whatever you can represent in the form of mathematical models, you will be able to easily optimize it. Optimization plays very important role because most of the time, all these real systems, they are very difficult to measure sometimes. So let's say your equation might have variables like friction. You might have things like inductance, which are very difficult to measure. Right. So using these approach, you can actually find those variables also. Right. So as you see now, all these 5 variables are being simultaneously changed, right? And these are the iterations. And now you see the simulated and the measured is very close to each other, right? So this is how it works. So this is known as parameter estimation. This will work under Simulink environment and onto this kind of problem. So you can have a problem that you can frame it inside Simulink and apply a parameter estimation to optimize, to find unknown variables, whichever technique, whichever result things you want to do it. Right. So this is very useful. I can stop it here if I want, or it will automatically stop also. So this is how you see here. Right. So what you saw, the green color, the motor resistance started with 3 value. It went down and settled down at particular value. Similarly, all these parameters. So there will be a time when these graphs will be almost straight line, and that will be the final optimized solution, and it will stop. You can even stop it like that. So once you want to see what are the final results, so this will be the final results, optimized solution. So we started with a resistance of 3, but we are able to get 1.5 as the right value. Right? So imagine, I mean, the application of these kind of technology. I mean, you can use this optimization for various complex problems. Right? If you had to do this on your own, imagine the hit and trial effort that you would have spent to basically get this. Right? Another thing is, if you see here, the experimental result that I imported does not need to come from experiment. You can even create it like a dummy data and load it inside. So that becomes your objective function like that also. So it doesn't need to come from there. So let's say you're working on MOSFETs, or you're working on, let's say, some other system which gives you a data sheet, let's say torque current characteristics, something like that, X and Y relationship. So you can import that relationship and use it to fine tune your system, right? So sometimes you do it, I mean, unknowingly you might be doing it in your projects or in your activity where you say, okay, my values, I'm not able to match that, whatever desired is there, let me change this value, because you don't know, right? So you can use the techniques in those kinds of scenarios where you are unclear of parameters and find those effectively, right? Optimization. So from here, estimation. When you start this estimate, then okay, which module? Okay. So what you have to do is, whenever you will get this model, you have to go to analysis here. So in your analysis, you will start using this parameter estimation. So when you click on this parameter estimation, this is what it will start. So when you click, this will open the same UI, this one, parameter estimation. This diagram? Oh, this diagram. This is this module is known as Symbolic. Okay, let me show it to you. So from how to come to this point is basically you have to come here. Okay, in MATLAB window you'll have Symbolic library here. So you have to click on this. Okay, so this will open Symbolic as a platform. So like MATLAB, Symbolic basically allows you to build graphical models, right? So this is a more graphical way of modeling a system, right? So this is also solving it, but Symbolic, this kind of modeling is suited for dynamic system. Let's say like spring mass, all the system that has time as a factor. MATLAB is suited for problems that are static in nature. Let's say linear equation, or the ones that we took like simultaneous, or like traveling salesman. Time related quantity. So it treats everything as a like a dynamic system, time domain system, right? Like traveling salesman problem, it is very static problem, right? It is not taking into account how much time it takes from going from let's say point A to point B. How much it takes, only the distance. That is static in nature. There is no time factor there. If you involve a time factor there, then it becomes a dynamic problem, right? Same is here also. So this motor is very dynamic system. So it has let's say the differential equation, everything at the back. So you cannot treat it as a static system. If you treat static, it will just be like 5 volts input, 10 RPM, but there will be no dynamics of it, right? So dynamics, what it means is, when you click on the scope, now see they are matching. The parameters are set, that's why they are matching. Okay, so what does dynamics say is that when you start a motor, this is how it starts, slowly, right? So when you switch on, it will take 1 second to basically reach that full speed, and when you do reverse, it will not do reverse immediately. It will take some time to slowly go down and settle down there. So these are the dynamics of a time domain system, and it is being able to capture within the Symbolic environment. So Symbolic as a platform is suited for modeling dynamic system. It could be motors, signal processing algorithm, image processing, antenna design. So many things are there, right? So you can use Symbolic as a platform to model such kind of system. Okay. So apart from this, okay, so just to show some of the advanced techniques, what I would like to show is Okay, let me just give you an option, highlight it. Okay, other things, because sometimes what happens is your systems require you to even go further and do things like global optimization, things like that. And how about searching minimas or maximas, let's say, into your problem statement. Okay, so when you take a term of global optimization, right? So what kind of problems are there in global optimization? So why does F-min-con have a hard time finding function minimum? Okay, because what happens is there could be several minima. Okay, if you see here, like there is one minima here, one minima here. So if you start at 0, you'll end up here. If you start at 1, you'll end up somewhere else. So different starting points, different minima. Okay, let me make it bigger. Okay, so different starting point, different minima. Okay, similarly, so you can even take for the engine also, right? For the engine also, if you start from here, it might go to this end. So why didn't this function find the maximum, right? It's these kind of questions, right? Why didn't, let's say, nonlinear regression find a good fit here? Right? Yes, that is also one question. So these are all examples of applying global optimization to this, right? So whatever we talked is also known as something like local optimization. You can even go to a global level and find a global optimization also, right? So in global optimization, typically the goals are we have to find the lowest, largest value of a nonlinear function that has many local minima and maxima, something like this. So there are lots of them. Okay. So problem would be that traditional solvers often return one of the local minima, not the global. That is what traditional problem is. So what solution that you can try is you use a solver that locates globally optimal solution. Okay, that is what the global optimization allows you to do. Okay. Now, so what we covered, solvers that we covered today was multi-start, global search, simulated annealing, pattern search, genetic. So these are all part of global automation, right? So this also slide also I have given in that folder, which you will get as an email. So these are all very big, vast domain areas. If you talk about multi-start, global search, pattern search, genetic algorithm, these are all very vast areas. Yeah, you can spend a lot of time in that area. So just to give you a flavor, like what you can do, you can all do these things within MATLAB also, right? So you can try out certain examples are there in that zip folder. Okay, like multi-start. Just I'm showing you what that is in brief. So in multi-start, you can start with different operating points, right, and get an optimized solutions, right? Let's like that. So if you start, as I said earlier, at time t is equal to 0, you end up in different solution. Time t is equal to 3, end up in a different solution. So with multi-start, it allows you to start at multiple points. You can start from here and get a good fit. Okay. So what exactly is multi-start? For some people who may not be aware of it, so it runs local solver from each set of starting points. Right? Local solver, you can run local solvers at different points. Right? So let's say imagine this as like a hilly area and terrain. Right? If you start from this point, you'll see that okay, that minima is there. If you start from this point, you'll see somewhere else. Right? So this is how a local minima looks like. So you can start from different starting points. Right? And this will give you all. This can cover the whole entire global space. Okay, something like this. You can even detect peaks function, and then find the local minimum and the global minima also, like that. And like what is global search, right? So global search is also one of the function. It's also multi-start algorithm, but it calls f-min-con at different operating points, starts points, right? And gives you the same and removes all non-starting points. So it is like a multi-start, but uses f-min-con also and gives you a better solution in a global term. Okay. So this is how it starts. Okay. So you can have a stage 0, run from 0, you'll find this, you have this region. So you remove this region because you already covered it, right? You start from here, go to this, you can get this minima, like that. So you can have multiple minimas and you use it, starting point could be different. Once you start from here, other states. So if you take several points, like all these points, and run optimizations on all these points, you can actually get a global optimization performed. Right. Similarly, here also, if you do it, you will be able to get this here, and you get this. So then you can compare all these and find the overall solution. Right. Okay. What is my global minimum? Like that. Okay. Simulated annealing. These are all terminology. You can actually look at it up, and all the examples also are given in that. So simulated annealing. Annealing is a mechanical process where you heat treat something. So this process of optimization is something like that. Okay. So it is also a metallurgical process like that, and based upon physical process of annealing. Right. So controlled cooling of metal allows atoms to realign from a random higher energy state into ordered crystalline state globally. Right. So using the same approach, also you can apply optimization here and run it. Right. So that's the approach is slightly different. So earlier we were taking starting points and finding the minima. Here we take it as a temperature and get to a minima. Okay. So we go from a point to another point, something like that, if you say. So by doing that, we will also get to that. Right. All these different algorithms, they have different performance level. They might give you a similar result, but they have different performance, and they are applicable differently for different types of problem. Okay. Let's say if it is a mathematical physics problem, it may be useful to apply sorting, and if it is a dynamic system problem, you may not be able to use this like that also. Okay. Pattern search also. So this approach uses pattern of search directions. Okay. Expands, contracts current point when solution is not found. Okay. So it looks like this. So you create a direction. You just like we started with. So you go up through let's say that engine optimization problem. So you can take a direction and take let's say once you achieve the minima there, you take a different direction like that. So it's based on direction. Okay. Something like this. But even we have this example. If you search it online, let's say you have let's say we take an example of Mount Everest or something, right? So there is a mountain. So mountain has different ways to climb, right? So you can actually use this global optimization to actually find the shortest path to actually climb up that also, right? So this pattern search was used to actually find the shortest path of Mount Washington also. This example also there. And this one is also a particle swarm, very popular example, optimization. It is also becoming popular because it is used widely in various fields because of its good speed and results that it gives, especially in the areas of image processing, signal processing. Right? So what it does is basically it's all about points. How do you approach those minimums, local minimums? So you can start from a point, search it, or you have direction, or you have point to point. So this uses swarm of particles. Okay. So what does is all these swarm has velocity, and they are affected by each other, right? So when you move, so it's moving like 10-20 people are moving together, or particles are moving together towards a mountainous terrain, and you actually move it towards with that terrain. So you'll also be able to get to that minimum faster. Okay, just like this. So you initialize certain particles. So you initialize particles all over the space with the velocity, and as you update velocity, you'll start getting closer to your minima automatically. Okay. And this is genetic algorithm. So genetic algorithm uses neural network, which allows you to basically use the evolution in biology to basically create neural networks and use those neural networks to basically come to the minimum, global and local both. You can use it for both the options, right? So how it looks is it has a different approach. Okay, so it has a selection, crossover, mutation. So it's like how the generation evolves. So that particular genetic algorithm uses this approach to come to that global minimum, right? That is how it approaches. Okay. Then so this is how it will look. So it will populate the the points initially in the space, right? It will select few goods for the reproduction. So select few good solutions for reproduction. So select this near this, right? And you'll see it will create another new generation of population, right? Again selects few, again generate new, right? So this process keeps happening until it has found the global minima, like that. So you can see very easily compare that all these techniques, they are trying to get you to that global minima using different approaches. Some approaches have pros and cons over each other, and all these approaches are equally good, but they are chosen based on the type of problem that you're working on. Let's say if you're working on something like image processing, you might choose particle swarm. If you're working on, let's say, something like electrical system that I showed, you can even go with very simple, let's say, even iterative, or let's say fmin con also. That also you can do very easily. Okay. Then this also we have already showed. You can even do it. Some of the applications of this could be circuit component selection. Let's say when you're building these circuits, right? What kind of parameters, what kind of components you need, you can even do that also. Like 6 components to size, only certain sizes are available, right? You can even perform these automation also, like mat voltage correct curve. Okay, so they fall into various kind of techniques. You can use any of this, like global search, genetic algorithm, pattern search. Okay. You can also, this also I showed in one example. So you can speed up with parallel computing on all these different optimization techniques using global optimization, or if you're using only just optimization. So optimization algorithm that support parallel computing are fmin con, min max, goal attain, pattern search. These are all supporting parallel computing. Okay. So this gives you a good speed up of your problems, right? So if you're using it on a desktop, and if you have 4 cores, you can speed up those applications that much, right? You can even take it advantage of your GPU and even take much faster optimization timing also, right? If your institute has a cluster, you can even deploy these algorithms to a cluster and even get a very high speed up, right? So many institutes nowadays, they have clusters where you have MATLAB installed, and you can actually use that cluster to fire a job that runs on that cluster also, right? So here you might have 4 cores, here you might have 100 cores also, like that. Okay, you can also get a lot of idea about optimization within MATLAB. You can go to our web page. A lot of links will also be there in that this document PDF that I have sent you. So there are webinars, videos, toolboxes, web demos also, short videos that will help you to just understand the toolbox much faster. Okay. So it's just a key takeaway before I think we are just 5 minutes from there. So today what we covered, it allows this optimization, you can apply it to various of your engineering problems. You can use it for teaching, you can use it for research, and it allows you to basically shorten and easily implement these algorithms into your task, right? Things like what we saw was linear, nonlinear, something even in more detail will be covered in the second session, which Zafar will be taking, right? So he will even go into more detail, like questions we got today in the session, like NeoPad, symbolic maths, how to use the user interface of Optim tool. So we will cover more that in more detail and show you how you can actually use for simple problem, just like open a Optim tool and just solve that. You can even use a MuPad, symbolic computing platform, to write those symbolic functions and solve it symbolically also, right? So what also we covered, how to better find minimal solution using different global optimization techniques also. This will also cover more in depth, and also parallel computing, how to speed up, right? So basically within MATLAB now we have also introduced parallel computing and distributed computing to scale up your application. So you don't have to change the program. You just have to write par4 and your program will be scaled up automatically. So anything, so otherwise you will have to write a code that is parallel computable, right? Otherwise, what will happen is your problem is very simple. I mean, you are able to solve it in MATLAB, but since you want a speed up, you have to write another program. Right? So that's the reason why I've given parallel computing, and this allows you to scale up your MATLAB model or MATLAB code or Symbolic model to speed up your time of execution. So that also is possible here. Okay. So what we have is any questions we can take. Otherwise, in this we have also given the email IDs, so you can even write to us when you start using this. We have also shared these files. I think within your the mail that you will get is will be this zip folder. You will get this zip folder, and inside this zip folder you'll have this whatever the presentation that I showed, and also this master files.zip. So if you open this zip file, you'll get this all the examples, right? So example, you want to run this traveling salesman, you can actually start it from here and run this mat. So this office location mat, these are all the data that was there. So you can use this file to run this, right? So you can go through all these examples, right? And if you want to know, let's say, more about it, you can even directly contact us, or you can even contact your coordinators or your professors, right? So various ways to get help from, right? So anything that you need, even after this session, you can even reach out to any of us, right? So with that, any questions we have? Otherwise, I think we have 5 minutes. Yeah, I'll tell. So this is how you can take. So this is the mail ID. You will also get it in the PDF document also, right? So you can actually write it to us, and so that we can take a look at your problem. So even if you, let's say, face, so it's not about this optimization. Even if you have anything that is beyond this optimization, let's say modeling for signal processing, image processing, or let's say controls, or you want to deploy MATLAB on Arduino, Symbolic, something like that, embedded system design, you can write it about us. You can just send a mail that we would like to do something like this. Do you have anything that can help us to build such kind of application? We will try to share you some examples, some application examples, how you can actually do your that project, right? Many things that you can find online, but if you need some more details, you can write it to us, because sometimes you may not get all the relevant examples there. So you want to some more clarification or in-depth answer, so we can also do that also, right?
Sir, if
Yeah.
possible, image can be converted to mathematical form.
Yeah, you can. So like I have
If you have an image data,
image
I
data.
want to work on that data. So in case of directly take the image and that features, we can convert that image value
In a data format. Yeah, correct. So I'll just open it. I think because a lot of people will be also working on image processing. So just open one application which talks about this particular app. So if you are using newer version, okay, of MATLAB 2012B onwards, you will be able to see this app here called Classification Learner app. Where is that? Here. So here, if you see, so there is a classification learner app. What this does is it allows you to basically import image features, basically, right? Let me show it to you how it works, because sometimes it is also good to just give you an idea about it. Okay. Like this. Okay. Now what it does is something like this. Okay. So you can take an image, right? And what it will do is it will convert image into a feature kind of format. Let's say like the color, the histogram, everything, it will take it out, like edges, yeah, homogeneity, everything. So it will take all the features. So if you see here, feature maps, so it can convert into different kind of features like colors, your edges, your histogram of the image, all the possible options here. And it will basically take out that data so that you can work on that data to create something as a models. Because sometimes directly working on image is very difficult because image contains so many things.
Earlier we have
Right.
to find out separate
Separate, yeah.
properties,
Yeah.
features.
Features.
And then list
Correct.
them and then word them.
Right.
So in place of that, you can merge
All this together.
all this.
So what this tool does is, if you see here, so you can directly import data. So it will create features here, different types of features, and make them into a data, just like numbers.
Numbers area.
Like for example, how many colors are there, or what colors are in close proximity, or what are the edges, like that. Once you have done that, what you will be able to get is, you can say, suppose you have 1000 images of your face. So you can say that this is a face, human face, or this is a dog, this is a sofa, like that. So you can get features of those 10,000 images and say this is a face, right? So you can train your algorithm like that. So again, you can use a neural network and do the same thing here, right? So you do the same thing here, and you can then predict, basically. Once you get a training, so it is saying that, okay, this is a keyboard. So the computer keyboard percentage is highest. So it is using neural network, CNN, okay, convolutional neural network. So it gives you a score basically. So that means it has certain data from training images. You are taking a live data, and then you're saying that based on this, I can say by this much percentage that in image it is this, like that. Okay. So all this happens when you take an image and bring it inside MATLAB and work on that features, basically.
This is also in new version.
New version.
Old version
This
before
is
10 or 10.
before 10 is very difficult. It's not like possible at all.
Okay, after 16.
Only if like 14B onwards. So in 14B onwards, you can even do these kind of things also. So that will allow you to even work on images very easily. Otherwise, if you have 10,000 images, very difficult to gather all that features data and train it and apply it to your actual application, what you want to achieve. That's it. Right. So anyways, I mean, definitely you can write it to us about those applications. So our email IDs will be there on that PDF also. You've already got this information also here, right? So you can write it to us, or start using that zip file also. Zip file has all the programs. So you can use it, put some part of the code from there into your work that you're trying to do, and use it the way you want it, right? So that is up to you. You can change it the way you want. Okay. So with that, I think we come to end of first session. We'll have a lunch break, and then we'll come back at 2 o'clock,
Yes,
right?
yes.
So we'll come back at 2 o'clock and have a more detailed session around optimization, right? Optimization, and also on the MuPad also we can touch upon, because I think many people want to know about symbolic math, and it is also
Hello. Hello. Hello.
Hello.
Sir, we didn't receive any script files.
हेलो
Hello.
हाँ सर आप ये जो आपने आज बताया है प्रेजेंटेशन, आपने बताया कि ये मेल आईडी पे आप हमें सेंड कर देंगे, तो हम आपको मेल कर दें इसके लिए पहले?
सर किस मेल आईडी पे करा सर आपने?
नहीं, अभी जैसे मैंने किया नहीं है, जैसे मैं आपको मेल करूंगा तो आप मुझे इसको मतलब मेल करेंगे?
सर मैंने आपको मेल किया सर dhirendra.singh@mathworks.com पे।
हाँ हाँ
सर इस पे अगर आप स्क्रिप्ट फाइल भेज दें तो हम इसको चला के देख सकते हैं सर, इसको डेमोन्स्ट्रेट कर सकते हैं।
ये किससे कनेक्ट हो गया?
हेलो हेलो हेलो
yeah. So we have not yet sent it.
हेलो
yes
Yeah,
sir.
yeah.
हाँ, प्लीज सेंड इट.
Can you hear us?
Yes,
Yes,
sir,
sir.
we can hear us.
Okay. So we have not sent it yet. We will just send you today. After half an hour.
Okay.
sir. Thank you.
To your local coordinator.
Sir, we are
Okay.
from MIT Merit.
Okay, okay. You'll get all the local coordinators will get the email
Okay,
ID,
sir. Okay, sir.
Okay, sir. Thank you.
and then you can take it from them. Yeah.
Okay. Thank you.
Okay. Okay. Sure. So thank you, everyone. We can meet after the break, lunch break.
बाहर से और पता चलता है।
हाँ, अगर एकदम से बाहर से हो ना
तो कोई नहीं पता।
कल है पेपर आपका सर, आपके डिपार्टमेंट का सेशनल?
कल? हाँ,
छुट्टी नहीं हुई? पता है?
हेलो। अच्छा ठीक है, नीचे ले आओ सर अपने साथ। आपके पास जाओ, मैं ले लूंगा। जब मैं नीचे ही पे हूँ ना, चलना होगा लेकर मैडम को दे छुट्टी तो नहीं है। कल फर्स्ट ईयर का पोस्टपोन हुआ है क्योंकि बच्चा ने पीसी को बोला कि हमने टिकट 15 दिन पहले से करा रखी है, मैं घर जाना है। तो ओपन इलेक्टिव केवल था फर्स्ट ईयर का, वो पोस्टपोन हो गया। अब ट्राई कर इंडिया वाला कुछ केस होगा तो वो तो शाम को भी पता चलेगा आज।
अच्छा, अभी कुछ नहीं है?
अभी तक तो मेरे
व्हाट अबाउट द वर्कशॉप, इसका क्या होगा?
अगर छुट्टी होगी तो वर्कशॉप भी खत्म। छुट्टी कौन आएगा इसके लिए?
नोबडी विल कम।
यानी से बोलेंगे तो भी कोई नहीं आएगा। घर बैठ कर देख सकते हैं। वैसे भी यूजलेस ही निकले, जिस आप चार्ज पढ़ा रहे हो उसको मतलब ही नहीं है। हमने कौन बैठा है, पता चल जाए।
हाँ,
कल वाला तबीयत तो
कल अच्छा था दामी का।
ये तो स्पेसिफिकली बोलते हैं कि उनके लिए है जो ऑलरेडी मैटलैब पे काम कर रहे हैं।
हाँ
अब तो ठीक था भाई, समझ में आना था कि हमारे यूज करेंगे।
हाँ,
जबरदस्ती बुला के उठा दिया।
ये भी अब आगे भी तो उसी नहीं करना है।
अब उसी ने करना, कल तक उसी ने
Nonlinear
करना।
है ना?
अब कुछ फायदा नहीं। बस अटेंडेंस के लिए बैठे रहो, किस तरह आगे तो खुद ही बैठता हूँ।
कल पावला सर क्या?
अब अगर तो वो थोड़ा बेसिक हो।
कल बस 1 बजे तक उसको फीडबैक एंड
क्या सर्टिफिकेट मिलेगा?
हाँ जी सर, सर्टिफिकेट्स आने
वहाँ से आएंगे। हम
विंडोज से
भेजेंगे,
आईसीटी।
तो हम भेजेंगे कि कौन कौन सी टीचर ने पार्टिसिपेट किया।
अटेंडेंस पे देखो शाम को खुद ऑप्शन मार्क करता है।
कौन?
जैसे कुछ लोग नहीं आए, फर्स्ट डे आए थे,
तुमको पता कैसे?
खाली छोड़ते ना साइन सेम होने चाहिए, तो घर पे नहीं ना सबका साइन।
ये जैसे लोग दोपहर में आके कर गए लेकिन यहाँ बैठ गए हैं, तो साइन तो
साइन तो
प्रेजेंट है।
हाँ, अभी के लिए तो वही है।
हाँ ठीक है।
मैंने तो ये बताया कि काफी लोग नहीं बैठ रहे, तो वो खुद ही कहते हैं कि किसके लेक्चर तो जाने ही है, किसी की ड्यूटी तो जानी है। लेकिन जैसे आपके नाम आए थे, हमारे डिपार्टमेंट में 4 नाम आए थे।
हेलो। अच्छी वाली राइट साइड हमारा काम भी दोनों बैठे चेक
हो गए?
इसमें अपन दे दूंगा ना, उनका तेरी फोटो कर दूंगा थोड़ा देर खत्म हो जाएगा।
हम भी जाती
क्या तो
भूल जाते हो, खुलवाना था ना, ये से अपन नहीं मिलेगा, लेके आते हो ना, ये तो शुरू होता है। मेरा बैंक में फोन में मुझे लगा चाहती हूँ।
देखता हूँ बेटा। हाँ ओके।
छोटी भी आवाज नहीं आ रही।
Okay. It is something. एक मिनट अभी हो रहा है फिर से स्टार्ट हो हाँ जी सर हो गया एक्चुअली ये ऑटोमेटिक रीस्टार्ट ले लिया सिस्टम सर का तो मैं एक बार कनेक्ट कर देता हूँ सर फिर से
कैंसिल कर दीजिए
मैं फिर से रिक्वेस्ट भेजता हूँ हाँ ये बहुत कनेक्ट है बस सर वो उठाइए शायद उनका कॉल होगा अमरदेव सर का अच्छा हो गया ना इसमें सर अच्छा
कर दे स्टार्ट Okay, good afternoon, friends. So, in the second session today, we have Mr. Zafar from Design Tech Systems. So, Design Tech is partner of MathWorks. So, in the morning, we had the application engineer, Mr. Dharinder Singh from MathWorks, who discussed with you the optimization toolbox. So, in this session, Mr. Zafar will discuss with you some topic on solving nonlinear problems using MATLAB. So I welcome Mr. Zafar.
Thank you, sir.
And thanks Zafar and Design Tech for coming here to conduct this session.
Thank you. Good afternoon to all of you.
Good afternoon, sir.
Okay, so we are going to take about that solving nonlinear problem with MATLAB. So before that, if you have any questions from morning session which Dhirendra has taken out, so we can take out within 5 minutes that thing also. or if you have specific some expectation queries, so we can deal with that also. Is it? Or should I continue?
Yes, sir.
Okay. Fine. So our topic is that solving nonlinear problem with optimization. So like in morning, we have seen multiple different, say, aspects of
Hello, good afternoon,
optimization.
sir. Hello.
Yes, please.
Good afternoon, sir. It is
Good afternoon.
myself, Abhilash from MIT Meerut.
Okay.
मॉर्निंग वाला सेशन काफी अच्छा था, बट सर एक बहुत छोटा सा एक रिक्वेस्ट है आपसे
Yes.
कि सर मॉर्निंग का जो सेशन था ना काफी फास्ट था.
Okay.
जो पार्टिसिपेंट्स बैठे हैं बिकॉज दे आर हियर टू लर्न.
Okay.
तो वो कोप अप नहीं कर पाए विद द स्पीड.
Okay.
तो सर एक रिक्वेस्ट ये रहेगी कि आप जो भी स्क्रिप्ट आप प्लीज कराएं तो थोड़ा सा टाइम दे दीजिएगा जिससे कि लोग हैंड टू हैंड प्रैक्टिस करते चलें उसके लिए.
Okay, fine.
जी.
Okay, fine. So I make myself that you should able to cope up with my speed.
It's a request, sir. Humble request.
I try.
Okay, thank you.
Okay, thank you. So solving nonlinear problem with MATLAB. So like in morning we have seen some of the linear problem solving, some different algorithms which are available in optimization and global optimization tools. So I'm going to cover up some of the nonlinear problems which are solved by optimization tool or by command line functionality. As well as that, on request, I'm going to cover up MuPat also, symbolic math, so that we are able to see that how we are going to solve different mathematics problem in traditional fashion, like we are solving on with a notebook and pen. So first, that nonlinear optimization problem. So basically, these problems are from side of minimizing or maximizing a nonlinear objective function. So in these kind of problems, what we require objective functions. If my problem having some kind of constraints, so constraints, that what kind of constraints are available in that particular problem. So that constraints could be linear or nonlinear constraints. So right now we are going to discuss about that nonlinear constraints which are available in the problem. Okay, it could be equalities or inequalities kind of constraints. So examples of these kind of problem, like analyzing design trade-off, selecting optimal designs, and computing optimal trajectories. So is it more of similar that which we have seen in morning, but the problems are different and algorithms are different. So like unconstrained nonlinear programming. So in unconstrained nonlinear programming, we are going to solve for a local minimum problem with nonlinear scale functions. So where we can put some kind of, without putting some kind of constraints on X, the range of X, whatever. So different algorithms are available in optimization tools like Cauchy-Newton, Nelder-Mead, and Trust region. So we can select out when we are going to see that command line functionalities or some app functionalities. So we are able to see these all algorithms. Similarly in constraint also, so over there we can put up some kind of constraint on X, that X should be bound in that particular area. Over there algorithms are like interior point, SQP, sequential quadratic programming, active set, trust region, reflective method. So we can use these algorithms directly on, again, in that app or command line functionalities. So I'm going to tell you that how we are going to use in app as well as that program. Okay, so I just quickly come up on that demo because of in morning we have seen some of the theories about optimization and all those stuff. So we are going to quickly come up on that demo. So first example is that nonlinear data fitting with MATLAB. So in this example, we are going to see that various aspects which are available in optimization toolbox for nonlinear data fitting. Okay. Okay, so what I have this M file. Okay, so what I'm using right now that MATLAB R2016B. So meanwhile, whenever we are going to cover up, I will show some of the features of this 16B also, that so that you are able to aware of that. What is this? So what version has been installed in different centers? Are you aware about that?
No, sir.
Okay.
They have different versions.
Okay, fine. So whether you have any version, this particular MATLAB functions or MATLAB scripts can run on those platforms, except few, because of those things will be available in new. So most of the things can run even in 2007 versions also. So first thing that we are going to set up our problem. So we have taken some data which is a 2-column vector. So I have some data points started from 0 to 2 with step of 0.1. And some arbitrary data we have taken in second column, which will be treated as my y data, and this will be treated as my t data. So initially what I'm going to do, I'm just going to segregate this t and y data from these columns. So I'm just segregating these columns. Hope so you are aware about that subscripting methods in MATLAB. So we have segregated that data with t and y, and finally what we are doing, we are plotting with red color circle markers those all those points and putting a title with this. So what I get a figure with red color circle markers of all data. So this is my nonlinear data, which I want to fit up by using optimization techniques, which are available in optimization toolbox. Okay. Now next thing is that I have this equation, y is equals to c1 exponential of minus lambda 1 into t plus c2 into exponential minus lambda 2 into t, which I need to fit up on my this particular data. So in which I have c1 lambda 1 c2 lambda 2 are the variables which we are going to assume as x. Somebody has some question?
No.
Okay. So we are going to assume that c1 lambda 1 c2 and lambda 2 as x, because of we know that whenever we are going to write a function in MATLAB, it is going to accept one as a variable, but we know that in a single variable we can input multiple number of columns. So what we are assuming that x as a variable, so x1, first column will be treated as c1, second column will be treated as lambda 1, third column will be treated as c2, and fourth column will be lambda 2. Okay, so here we are writing out that complete equation, that x and x data is going to pass on. So this is basically function handler. So how functional handler is going to work on MATLAB? So whenever we require that we should call some of the function indirectly into my program. So what we could do, we can define as @ as a function handler. So what I could do, I can simply check out in this place that like x is equals to @. So I'm putting random. So what it will do, it will store that complete random functionality into x variable. So as soon as I put x and some values I'm going to input. So if I haven't defined this x as with function handler, what it will do, it will find out that subscript or indices in my x variable, if x variable is available, and put that values in my command window. Now what it will do, it will create a 2x2 random matrix, because of we have defined this random function in x variable. So as soon as I execute, it will generate some 2x2 random matrix for me. So similarly in this place also, what we are doing, we are just defining that x and x data, because of I cannot directly pass on, I don't know that what will be the x value and what will be the x data value, which I am going to pass on into my this particular equation. So that's why I have taken with, so that this x and x data will be handled by this particular function in which we have written x1. So it is similar equation which is here mentioned. Okay, so we have put it like x1 into exponential minus of x2 into x data plus x3 into exponential minus x4 into x data. So now I have this equation stored in this f variable, which I am going to call up for optimization. Now what kind of optimization techniques we are going to use up? So in MATLAB or in optimization, we have a dedicated functionality available for fitting, which is known as least square curve fit. Okay, so we are going to use that. So before that, what I'm going to do, I'm just going to define some arbitrary initial conditions. So we are saying that our C1 is be treated as 1, lambda 1 has been again 1, C2 as 1, and lambda 2 is treated as 0. So we are defining that initial condition as 1, 1, 1, and 0. So it should be an array, a row vector. So we have defined as a row vector. Now we are directly passing on this to function, which function we have stored, initial condition, t and y. So t is our time input and y is our main input, which I'm going to fed up in my least square curve fit algorithm or function, from which we are going to extract as output x normalization value. So wherever we don't require some of the input, so we put till this tilde character. If we want to know each and every output argument, that what this output argument will contain, what we could do, we can simply go in this option and select out this help. So it will list out that complete help about that particular function. Like here, it has pop up this particular box in which this least square curve fit is available. So we are able to see that each and every point on this place. Okay, and then finally what we are doing, we are plotting on the same figure that what will be the fitted data with this. So what I get fitted curve on my existing curve which I have earlier created. So now it is showing that. Now different approaches are available. So right now we have seen that this particular one has been defined by initial guess 1, 1, 1 and 0. What if we change that initial guesses? What will be the result? Or if my problem has linear and nonlinear both kind of constraints available, how I'm going to work on that one? So for that, what we are going to use, we are going to use one function which is available in optimization, function of minimization unconstrained. Okay, so fmin we are going to use up as a function, in which again what we are going to do, we are going to minus this y data and squaring that complete function. So this function has been x and t value is going to pass on. So x already has been generated from this place. Y we have here. So we are squaring this so that we are able to get this a new function, f sum squares. So sum squares is a function. Now to use up different options in optimization, we use this particular function optim options. Now in this place we can define what kind of function we are going to use or method, or in that particular method what algorithm we are going to use. So as I said that Cauchy-Newton is an algorithm which is going to use for nonlinear problem solving. So what we are saying that we are going to use in this function of minimization unconstrained function, algorithm should be Cauchy-Newton. So we can define according to our problem that what kind of algorithm is going to use in that place. And then what we are doing, we are just passing on that same function or objective function with initial conditions and options which we have defined in this place, so that we are able to take out that what will be the output of this. Okay, so what I get, so I'm getting these outputs on my command window also. So like first time whenever I have run, so what it says that sum of the x values, so for x1, x2, x3, x4 means c1, lambda 1, c2 and lambda 2, all those values has been shown in this place. Exit flag, so what will be the exit flag is there, different output structure has been shown in this one, that how many number of iterations has been run by that problem. Function count, that how many number of time that a specific function has been called, what kind of algorithm has been used. So by default least square curve fit has used truss region reflective method. So it is going to show all those things, and it is going to show that local minimum possible values has been shown. So some message has been displayed in this place. Similarly, that whenever we have run for unconstrained, so unconstrained values has been shown that. So two different results has been come up whenever we are using two different methods or algorithms. Okay. So Okay, so now what we are doing, we are splitting that problem with linear and non-linear problems. So we know that if my problem of a least square is a linear problem, so we can solve by backslash operator also. So in MATLAB, one operator is there which can easily solve my linear problems. So what we could do, we can define our complete problem as a backslash. So for that, what we have did, we have created a file which is known as fit vector. So in this fit vector, we have assigned that my complete equation, okay, and we just define that. So for each and every value of a, we are going to create with this backslash. So it is going to basically solve a into cy. So this is my linear parameter equation, in which we are going to find out that what will be the value of c, so that we can further work on. So and that return it is returning that second estimated response based on c. So a into c. So whatever the value of c has been generated. So what we are passing on this one, lambda values, x data, and y data. So whatever the new x data has been generated, as well as that existing y data is there. So we are going to pass on so that we are able to find out a linear problem in this. Okay. Okay, so now what we are doing, we are solving it as a two-dimensional problem. Earlier that problem has been treated as a four-dimensional problem because of we have four different variables which we need to find out. So we are treating it as a two-dimensional initial point, lambda 1 and lambda 2. So lambda 1 and lambda 2 is going to pass on in this place. And again, we are creating f2 as a objective function with fit vector, which require this x, t, and y. Okay, so x is initial guesses, t is nothing but time, and y is my y data. And again, we are going to solve it for least square curve fit problem as a two-dimensional, in which we have removed that non-linearity. Pardon, sir? Fit vector is a function. It's not a solver. This is a function. It's a ready customized function in which you have seen that it has been used this backslash operator. So whenever we have some linear equation, we can easily solve by using backslash operator. We don't need to do some kind of fitting or optimization techniques on that one. So it will automatically give some results. Okay. Okay, so this fit vector is nothing but that particular function file. Okay, so we are passing on into least square curve fit and find out that what will be the result now whenever we have treated my problem as a two-dimensional problem. So what I get when I solve my problem with a two-dimensional problem, okay, what it says, that value of C has been provided as 10.586 and C1, C2, both values has been shown in this place. Okay. Now, further, what we are going to do, we are going to split up again my problem for more robust, so that we can find out that earlier whatever we have done as a solution, that solution is correct or not. So what we are doing, we are changing our initial conditions a little bit. So instead of 1, what we are doing, we are giving initial condition as 5. Some bad values has been given. Okay. So again, we are solving it for with least square curve fit, and this x0 bad is going to pass on in this place. So whatever the new initial conditions has been there, and same t and y is going to pass out in this. And we are plotting on same figure so that we can check out that what will be the changes in on output. So as soon as I execute, so it is going to give this particular thing. So blue one is that global fit, whenever we have seen that my problem as a global fit, and green one is that whenever we have provided a bad local fit in some bad initial conditions. So only changing one initial condition has changed a solution a lot. So we have to make sure that in initial guesses should be good enough. So that's why whenever we know that my problem is a local minimum problem, so we use solvers from optimization toolbox. When we don't know that my problem is a global minimum problem, so definitely we go and use that global optimization techniques so that it can easily solve out and provide better results. Okay, so this is the first example in which we have seen a symbol that how we are going to use least square curve fit, how we are going to break up with linear and non-linear by solving as a 2-dimensional or 4-dimensional kind of problem. Sorry. Okay, any question? Okay, so can we go ahead on the next one? So now, second problem which we are going to take out is by solving optimization nonlinear problem by using optimization app or a GUI. So in which what we are going to do, we are going to use this fmin con solver, where my problem is that minimization of function of x, x1 square plus x2 square. So we have to solve for x1 and x2, and some of the subject of constraints has been given. So a bound has been given 0.5 less or equal to x1. A linear inequality has been given, minus of x1 minus of x2 plus 1 is less or equal to 0, and some of the nonlinear inequalities has been given as this much. So what we need to do, first we need to write down objective function and nonlinear constraint function, then we are able to solve this problem. Okay, and for that some of the initial guesses also has been given for x1 as 3 and x2 as unit value. Okay, so we again quickly back to on MATLAB environment. Okay, now to write down objective function we require script files in which we can write down our objective functions. Okay, so you are aware about writing a function file, or should I let you know? Aware. Okay, so what I'm going to do, I'm just going to open this objective function. So in this presentation, objective function shows that x1 square plus x2 square function of minimization. So here what we have written. Okay, so exponential, sorry, I think so I have opened wrong one. So this one, a function of x1 square plus x2 square. So as I say already that these kind of objective functions or constraints will requiring one input, but we know that we can define in one variable of MATLAB multiple number of columns. So what we are doing, we are just passing on x as an input, but we are dividing it to x1 square and x2 square. So whenever you have multiple variables available in your problem, better you can treat it as a single variable and break up with column. If we are going to define x1 and x2 as a separate variable, it's never going to solve your problem, and it will never accept by tool or a function. So it should be defined as single variable in this place, but multiple number of columns. Okay, so what is happening when I say that x, so or x1, so x1 is a separate variable. When I say that x2, it is again a separate variable. So now what I'm doing, I'm defining my two input values into two different variables. But these methods like function of minimization with constraints, function of minimization with unconstrained, least square curve fit, all of those functions, GA, simulated annealing, what it require only a single variable. But that variable could be of multiple number of columns. So what we are doing, instead of defining like this, so what I could do, I can say that, sorry, oh, that's okay, x1 is equals to 1, okay, and x2 is equals to 2. So what it says that I have two different columns available. So I'm passing on my data still, but in a single variable. So for that, here we need to assign that it should be a single variable, and here we can split it to multiple number of columns. So it says that x1 square plus x2 square. Okay, so this is my objective function. So to writing a function file, definitely we need to write a function keyword, my output arguments, If we have multiple output arguments, we should define into square braces separated by comma. A equal symbol should be defined. A unique name should be defined in this place, which is not an inbuilt function name. Otherwise, your function will get conflict and you get poor results. And my input arguments. So if multiple number of inputs are there, so we can separate with comma, but not in the case of optimization problem. In optimization problems, we must define it as a single variable. Okay. So this is my objective function. So according to this problem, we have written an objective function. Now my next step is that I need to define these bound linear inequality or nonlinear inequality. So these things I can define directly into my optimization app, but I cannot, because of these are single equations. I can easily define into my optimization app, but here are multiple number of equations has been given for inequality. So for that, definitely I need to write down a nonlinear constraint function. Okay, so for that, what I'm going to do, again go and open up that nonlinear constraint file, in which again what I have, so this is for inequality and equality. So what is my requirement? That I should define that nonlinear constraint as inequality. So for that C, so it one thing we have to note it down, that whenever we are defining some kind of nonlinear constraints, so this equality and inequality, both variables should be defined in as an output, and one variable should be, if we don't have any output for that, so it should be defined as a empty. Otherwise you are not able to solve your problem. It gives error. Okay, so same funda for function, that function line, output arguments, function name and input. And according to my complete inequality equations, we have written down like x1 square minus x2 square plus 1. So everything we have taken it to other side of negative, equal sign, and just define that equality as empty. So inequality we have defined in this place. So now what we have objective function, we have nonlinear constraint, both things available. Just what we need to assign in app, these two things, and bound linear inequality as well as that initial guesses. Okay, so there are several ways to launch optimization tool. Okay, one way is that I can directly go in apps and this optimization is available in this place. So we can launch this optimization directly, or what we could do, we can simply type optim tool on MATLAB command prompt. So this will launch optimization tool. Okay, so I'm going to launch this optimization tool. Okay. Okay, so here what we have. Here we have 3 panes available. One is for problem setup and results. One is for different options which are being invoked according to what kind of solver method we have chosen out. And the last one is that quick reference, so that we are able to find out what will be the help for each and every section which is available in this optimization app. Okay, so what we are going to do, we are going to choose out that what kind of solver method we are going to choose in this place. So all the solvers has been shown in this place, like fgolatine, fmin bound, fmin con, and so on. Least square curve fit also has been given. Least square for nonlinear squares also has been given. So we can choose out anyone. So like right now what we are doing, we are choosing it for fmin con. Okay. Accordingly, it will show that algorithm, what algorithms are available in this place. So what I'm going to do, I'm going to choose active set algorithm right now, because of it is going to run all of the algorithms and find out a better solution for me. So I'm going to choose that active set algorithm right now. Okay, now I have to define my objective function. So my objective function should be defined with function handler. So @ symbol and my function name. So I have given a function name as, so this is my objective function app. So this is my function, complete function name. So I just need to define this name in this place. Okay. Now I have to define some of these start points. So every optimization problem is requiring an initial guess. So we have already seen in that PPT that 3 and 1 for x1 and x2 are the initial guesses. So what we could do, we can simply define. So within square braces, we are defining 3 separated by semicolon 1, 2 different rows basically. Okay, so we have defined 2 initial guesses in this place. Okay, now what we need to do, we need to assign some of the inequalities, equalities, bounds, or nonlinear constraints. Okay, so according to our problem, if we take a look in this place, what we have bound available, but this bound will show that 0.5 is less or equal to x1. They haven't given any bound of x2. So what we are going to do, we are going to define bound as 0.5 to minus of infinite. Okay, so because of we don't have x2 bound, so we are giving it to minus of infinite so that it can solve. Okay, next, this linear inequality. So whenever we have linear inequality, what we do, we simply write down in this place, inequality or equality. For nonlinear we have this one, for linear we have this one. So what we are going to do, we are going to choose out that what will be the values for linear inequality. So if we say that this equation will become like minus x1 minus x2 is equals to minus of 1 when we equate things. So it will become, this equation will become minus of x1 minus of x2 is equals to minus of 1. Okay, so what we could write, so this will become my a part. So coefficients of x1 and x2 will become as -1 and -1, and the b will become minus of 1 again. So what we could do, we can simply go and write down minus of 1 space minus of 1. Okay, and here also I'm just going to write down that minus of 1. Okay, so in our problem, this bound has been given as 0.5. So we are saying that minus of infinite. So we don't have any upper bound. For x2 we are writing down that minus of infinite, but we don't have any upper bound. So what we could do, we can simply write it down in this place also, that these lower bound will be 0.5 and minus of infinite. Okay, so we have defined 0.5 and minus of infinite in this place. Now we have to define this nonlinear constraint. So nonlinear constraint also we are going to define with @ function so that it can become function handler. So what I do, I simply take that name of this and define into my So what we have did, we have just defined each and everything, and we are saying that derivatives as approximated by solver. Other options, so here multiple options has been shown that what will be the maximum iterations. So by default it is 400. What will be the maximum function evaluations, that how many number of times it is going to evaluate. So if we need to put up some kind of criteria, so we can put up directly in this. Otherwise it will by default take some of the criteria for you. If we have parallel computing option, so that option also we can use in this place. So just we need to select out a simple checkbox that use parallel. It will automatically parallelize my problem, complete problem. So here also we are going to show that iterative. So every iteration it is going to show into my MATLAB command window. Okay, so right now I have done my complete setup. What I need to do, I need to simply click on this start option. So as soon as I click start, it will start solving my complete problem and show those number of iterations. Oh, sorry. That on 7th iterations, it has find out that feasible results. Objective function value is 2.0, some value, which is satisfy that local minimum. And the value of x1 and x2 is 1. Okay. As well as that, it is going to show some of the iterations in this place also. That so on 7th iteration it has stopped that thing, but on 6th iteration, 7th iteration it has. So on 0, function count will be 3, function value will be this much, constraint will be this much, and so on. So it is showing each and everything to me. So it's showing that infeasible start point as in modified twice. So everything has been shown in this place. And here also that active inequalities to within options constraints. So it is showing that 10 to the power minus of 6, 3 into 10 to the power minus of 6, 4 into 10 to the power minus of 6 with tolerances. So it has shown each and everything to me. So what we have did basically, just initially we have created our objective function as a function file in MATLAB, nonlinear constraints also as function. Start that optimization app, choose out solver method, algorithm, what algorithm is going to use for that, define objective function with @ handler, choose out derivatives method, so it approximated by solver itself, some of the initial guesses, so in start point need to be defined. If linear inequalities or equalities are available, so we have to define linear inequalities also or inequalities also. Bounds, so if some of the bounds are available, so we have to assign those bounds also. And nonlinear constraint,
Lower bound 0.5 minus infinity.
0.5 and minus infinity. Two, there are two.
X1 and X2. For X1 and
For an x1 x2.
So why don't you put a semicolon? Oh yeah, two.
It is separated by space. Because of my x1 and x2 treated as a column.
For a start point, you
I have put it as a semicolon. Reason, because of it is going to act as a, it is going to call as a point values. So it is whenever it's going to call, it is going to call for x1 and it is going to call for x2. Okay, and then just we choose out and start that problem solution. So we get that minimize objective function and that values also. If we want to export this problem setup into my MATLAB workspace, that is also possible. So if I go in this place, what I have export to workspace option or generate code option. Both options are available. So if I click on this generate code option, what it will do, it will generate a file for me. So I say that it's okay. So what it require? It require that initial conditions x0, inequalities, b inequalities, lower bound. So whatever the values we have assigned. So some file name it has automatically taken. It is going to pass provide me that x function of value, exit flag, output lambda. Multiple outputs are going to pass on. Optimization options. So fmincon display is set as iterative. Algorithm is going to set as active set. And then it is going to call this fmincon for me, and in the fmincon we are passing on that nonlinear constraint as well as that objective function. And when we say that export to workspace, it is just going to export a structure variable. So it is going to export all of this stuff for me. That a complete problem, only options, or that complete structure MATLAB. So what I do, I just export everything to my MATLAB workspace. So these all things are available. So if we optim problem, so what it shows that complete thing. What will be the x0? What will be the objective function? So complete problem setup is there. So what we could do, we can store these and solve out later on also, or results also same way. Optim results. So it is going to meet that results also. So everything has been come up in this place. Okay.
After exporting, you can type that.
This command.
After exporting.
Yes. So basically these are my variables. So I'm just going to see that what is available in my variable. Either I just type down that variable name into my command window and it will show that contents of that, or I just double click on this variable name and it will open into a variable editor. So basically it's a structure. It is going to show each and everything. Now if I want to see that what will be the values of x0, again I double click on x0, it will start showing me that values of x0. Initial guesses 1 1. There will be no value. So it didn't create these variables also, because of these will come up whenever we are going to export these variables from my app to MATLAB. And if I need to solve in parallel, so you see that direct option has been given. Even I don't need to write a single line of code. Evaluate in parallel. So any question for previous or this one example, or should we continue? Optim problem? No. So basically what it do, like whenever we have this app and I just choose out that export to MATLAB workspace, you see that it automatically show that what it is going to transfer. I can change this name also, but it is saying that export problem and options to a MATLAB structure named this much. If I select out this option, so I can include this also, include information needed to resume this run. Like I'm running some kind of simulation of optimization and it is taking quite longer time, but I have limited time right now. I need to run it later on. So what I could do, I can include those things also. And what I do, you see that here options has been given as pause or stop. So I can stop my problem at particular iterations and later on. Because of right now we are running some smaller problems, but optimization is a process which sometimes takes hours or days also. Okay. Okay, so now another demo with nonlinear equality and inequality. So right now we have seen by app that similar thing we can perform by using command line environment also. Okay, so for that, as I said, that we need to create this nonlinear constraint file in which it should be defined as nonlinear inequality and nonlinear equality. Both options are should be defined in my file, function file. So the function of cx represent that constraint cx is less or equal to 0. The function c equality x represent the constraint c equality x equal to 0. So it is going to represent both of the things. So now here what we have a problem as x1 square plus x2 is equals to 1, and the nonlinear inequality is constraint x1 into x2 less greater or equal to minus of 10. Okay, so we have rewritten them and write like this: x1 square plus x2 minus 1 is equal to 0, which is equality, linear equality, and x1 into x2 minus of 10 is less or equal to 0. So simple steps are there. Write a file of objective function.m. So name could be any. You can choose name. Step 2, write a constraint function, okay, of equality with for nonlinear constraints, and invoke constraints with optimization routine. So that routine could be any with MATLAB command line or app. It totally depends on you. So like here, what I have this objective function in which we have written an objective function as exponential of x1 into 4 into x1 square plus 2x2 square plus 4x1 into x2 plus 2x2 plus 1. So this is a complete objective function. Now same way nonlinear constraints for we have written this. So this is nonlinear inequality constraints and this is equality constraints. So like earlier we have seen that we don't have nonlinear equality available, so we have put it as an empty, but here we have, so we are just passing on that equality constraints in this place. To solve, the method is quite simple. Like we must define that everywhere that initial guesses should be defined. Then options, that what algorithm I'm going to use. So at fmincon we are going to use in which algorithm is going to use as SQP, solver and then algorithm. So SQP is going to use in this place. And directly we are solving with fmincon objective function. So initial guesses we have defined. So we don't have any of these which are treated as linear inequalities, linear inequalities, lower bound and upper bound. So we don't have any of these things. So we must define as a empty variable. And then finally that my nonlinear constraints and the options which I are going to use. So options, like right now I have chosen one option. In app I have chosen one more method, iterative method. So I can define one more option in this place, and so that it will be automatically taken care by this variable options. Okay, and finally what I get that solution of x and function value. So if I execute, I get this result directly into my MATLAB command window. So x value of x1 and x2 and that function value is there. Same thing we can solve by nonlinear constraint with gradients also. So over there also that problem setup is same, that we have to write down an objective function with gradient. So gradient should be defined in that objective function and a nonlinear constraint again and the gradient of nonlinear constraint. So gradient also should be defined. And finally we can invoke with any of the routine app or so like this function. So this is the same function which we have used in that place, and the nonlinear constraints has been defined. So like here, so till now we are writing this, but if my problem has some kind of gradient, so we need to write this gradient also for the objective function. Like here they have written as if number of argument output is greater than 1, then gradient value should be function plus exponential x1 into some specific gradient has been written. Similarly for constraints also, here also that if it is greater than 2, it should be these values. So it totally depends at what kind of problem. So solution of a optimization technique in MATLAB is same for all. Just we need to work on all objective and constraint function and what kind of algorithm we are going to use. See, for solution I have used similar things. Just what I did, I just defined that x0 as an initial starting process, some options that fmincon. So until at that moment we had chosen this in last example. Here what we have did, here we have defined that in options we are going to add up objective of gradient, which is defined, constraint gradient, which is defined. So we have put it both as true. If we are not defining this, even if we have defined that gradient value equations in my file, we are not able to solve as a gradient problem. Lower bound as empty, upper bound as empty, either we can define or not define, that's not a problem. And that f min con. So solution is same, just we are changing different options or functions, nothing else. So like if I am going to solve with this, I'm getting this as a result. So because of it has a gradient. Equation is same like earlier which we have used. So similarly, like multiple other things are available. So if I go in documentation of MATLAB, which is available offline, online, in both of the ways, in optimization toolbox, we have simply nonlinear optimization group has been given. So we can go in nonlinear optimization over there, that unconstrained problem, constraint optimization, and multi-objective also. So if you have multi-objective problem, the way is same. But that objective function should be a single, not multiple objective functions we can write. In a single file, we can write down multiple objective functions. So methods has been given for each and every aspects. So all further examples with parallel computing, with ordinary differential equation, algorithms, and other theories. So explanation for each and everything has been given. Same way for constraint also. Like in morning that Dhirendra has shown symbolic option also. So that also we can solve with this one. Okay, so any question on this? Okay, centers. So any question from center? Different centers? Any questions? No? Okay, so we are going to take our next topic of symbolic math computation with MATLAB. So in this also we can solve out on linear and nonlinear both kind of problems. Now what is the difference between MATLAB and this symbolic math? First we are going to discuss that and then we start this topic. Okay. So whenever I need to solve an equation in MATLAB, like I'm just saying that f is equals to a into x square plus b into x plus c. A quadratic equation is there. So what are the constraints to solving this particular problem in MATLAB? I need to find out roots of this. If we are solving with MATLAB, I must know value of a, b, c, and x. Otherwise, I cannot solve. Because of MATLAB is a numerical computation tool. Even if I execute this right now, what it will do? It will say that undefined function in variable a. If we define variable a value, it will start asking for x, then b, then again c. So values must be defined. But what happened in our routine MATLAB, maths problem? We have some equations. Initially, we don't know the values of that. We first solve that problem and then we put up some values and find out that, oh, this is the solution, exact mathematical solution or numerical solution of this equation of this. So how we are going to solve in MATLAB? And MATLAB will not help for that. So for that, what we require symbolic computation tool from MathWorks. So it is a tool on top of MATLAB which will perform some kind of symbolic computation. So like first I will let you know that by command line, and then it has a complete engine. Through that engine we can solve multiple problems. Okay, so like what I'm going to do, I'm just writing down one command, syms. So syms is a command which will allow me to convert my variable as a symbol. So what I do, I simply say that I have a, b, c and x, 4 variables are there. So what I'm going to do, I'm just going to write it down, a, b, c, x. Okay, so what it will do, it will store my in my MATLAB workspace these variables as symbol. Okay, so this has been come up. Now you see the difference. So what I'm going to do, I'm just going to take one more variable and writing down some of the random values of 2 cross 2. Okay, now it clearly shows the difference as an icon. In this symbol variable we have some kind of box icon has been shown. Here we have some kind of cell icon has been shown. Okay, so it is a double value which is numeric value, and it is a symbol value. Now earlier what we have did, we have called this f is equals to ax square, this equation. What we get error. But right now whenever we call this equation, what it shows? A complete equation, a complete quadratic equation. To solve or find out that roots of this equation, I just need to simply type down that s is equals to solve this f. So what I get? I get the roots of that complete equation, which we have learned. Minus of b plus minus b square minus 4ac divided by 2 into 2a. So this we have learned. Now what we could do, because of earlier might be we don't have value of x, but right now what we have values of a, b and c. So we can put up these values of a, b and c and find out that results, numeric results. What will the floating results? So this is the one way that we can perform some kind of symbolic computation on top of MATLAB. Now everything could be solved on command window also, but in earlier version that option is not available. So every symbolic computation, for that we need to go in an engine which is known as MuPad, which is a part of Symbolic Math Toolbox. Or right now that things are available that we can convert that thing as a MATLAB code also. Yes, please.
Hello. Yes, sir.
Okay. So what I could do, I can simply launch MuPad. So one way to launching a MuPad, we just simply go in this app section. In this app section, we are able to see that I'm not able to see that MuPad here. Symbolic Math Toolbox. I don't know. So no problem. So what I could do, I can simply say that MuPad on command prompt itself. So what it will do, it will launch that engine, MuPad engine. In that engine, we have all the functions which are related to mathematics are available. So you see, in this place, we have all the functionalities available. Either we have a derivative problem, limits problem, summation problem, integration with limits. Okay, all kind of problems for problem of expansion, factorial, and other also. So all has been shown in this place. Other calculus problems, power series problem, matrices, polynomials, some combining problems, some need to rewrite some kind of differential, some evaluate in numerically or Boolean. So all those options are available. So what I need to do, I need to simply write down that equations in this place. So what I'm doing, I'm just writing down that. Say suppose that I'm writing down as x square plus 3 into x plus 5, and this is my complete equation. So as soon as I write it down in this place, and execute. So by enter, I'm just executing my equation. So what it says that x square plus 3x plus 5. So like in MATLAB, because of MATLAB is a numerical computation tool, to use these equations as a symbol, we have to write down that sims command. But here we don't need to write that sims command also, because of it is that engine on which that sims command is going to work on. So we need to directly write down my equations in this place and start executing. Okay, or even I can write it down plotting commands also. So I can write some plot f. So what it will do, it will create a plot of this function for me. So x square plus 3x. So right now it is treating x values as -5 to 5. If we have our own values, like from 0 to 10 we need to define, 0 to 100 we need to define, so we can define that values also in this place. Without defining values we are doing. No, so sometimes it happens that you have some mathematical equations over there, you don't have some of the values available for that. You need to initially solve, get back results, and those results is required in MATLAB. So in that case, we can convert this as a MATLAB code. That option is there. So there are two options for conversion. So we can see later on that thing. And it is not that much that we are going to solve this. Like, hope so you are all our faculties. Okay, so you want to prepare some kind of, say, documentation for your students, or some kind of say assignments for your students. So what we could do, we can define external contents also in this one, some images, some of the text, and it can work on. So I show that a complete example of this. So I just close this right now, and so this is a simple example. Like we have written some of the header line, and we have defined some of the text also. So those options are available, that what we have to define. Either we need a calculation, or we require a text paragraph. So we can choose out that what is our requirement. Sorry. So like here we have written some of the text as well as that functions. So we are going to solve this calculus problem. So what we are doing in this place, we are solving for f is equals to 0 for x. So if we have two variable problem, x and y, so we can assign also for which particular variable we need to solve this.
So this command is given by from solver.
From MuPad. This is MuPad. This is MuPad.
Can you give an example how to solve this problem?
Okay.
For example, I want to solve this function is equal to 0.
Function is equal to
MuPad command.
MuPad commands. So this is MuPad command. This is MuPad.
No, you solve
so any equation, like this is a equation.
Yeah, okay.
So either I can just enter in this place, or in this notebook option is there evaluate.
Okay.
Or if I need to evaluate each and every line, so I can say that evaluate all.
No, only
one line.
You are evaluating what? It is equals to 0 or it is equals to something else?
Okay, so first I just generate that this equation f. So this f equation has been generated. So what it's saying that solve f is equals to 0.
You can also use the there's a command. It is general math command.
Right.
It is solve.
So this is same command.
And that's it. Yeah.
So in general math, you are saying that this solve.
Yeah.
So it is showing us that what we have to solve: exact, numeric, linear system, polynomial. So like.
So I think it is polynomial.
Excuse me, sir.
Yes, please.
सर जो फॉन्ट साइज है वो बहुत ज्यादा छोटा है, दिख नहीं रहा सर, और जो लेफ्ट हैंड साइड की विंडो पैन है वो कटा हुआ है, तो हमको
Okay, just hold on. Is it clear now? Is it clear?
और थोड़ा सा
सर इसका फॉन्ट कलर चेंज हो सकता है?
ये रेड वन,
हाँ जी, अगर इसको किसी और में आई थिंक तो ब्राइट हो जाएगा ना ज़्यादा, तो नहीं ज़्यादा।
okay, I just check that calculations, increase text.
Color to text color.
Which color should I give it? Black?
हाँ जी सर, ब्लैक कर दी।
But it should be, I need to again light it up.
अदरवाइज सर थोड़ा और जूम कर दें करके
मतलब जो नेक्स्ट लिखेंगे वो फिर ब्लैक आएगा।
So is it clear now?
Yes, at MIET now sir it is visible.
yes sir, it is now.
So if I unzoom that, it is also visible now?
Yes sir, visible.
No sir, now this font size now it is fine sir. Earlier it
Okay,
was
fine.
too small. Thank you.
Okay. Okay, so you were saying sir about this general math and solve. So these are different methods, like exact solution is required, numeric solution, linear system, a polynomial. Like as soon as I select out a OD, so I need to define that OD. So this is a function of such kind of thing. So in which I have already a function. So here also what we are able to see that solve, we need to define some kind of ODE equation. So ODE will a function. ODE will treat as a function and ordinary differential equation. And for what we have to solve.
So see, for example, you have mentioned the one equation that is your x cube something.
Right. This.
So I want to know what will the value of x for f is 0.
So it has given. Two roots has been given because of its a quadratic equation. So it has given that minus of under root of 31 by 5. So what we have said that it is going to solve for f is equals to 0 for x. So it is going to solve this x.
Is there any direct command or?
This is a direct command. This is a direct command. And here we are just going to find out that floating values. That what is the floating values for this one. So what we have multiple number of functions has been inputted or commands has been inputted in this one, and we can solve each and every by using this evaluate all option. So now it has solved each and every line of my code, and we are able to see that what will be the outputs for each and every section. Okay. Other thing is that what we could do. Like as I said that we have to create some kind of assignment, some kind of documentation of this one. So what I could do, I can simply go in this file option, and in this file option, I have an option of export. So as soon as I say export, it has multiple options. HTML, PDF, a plain text file. So like I need a PDF file for this. So what I could do, I can simply say that I need to generate a PDF file for this. So what it could do, it could generate a PDF file for me, and this PDF file will be available in this place. So all the curves and everything has been come up in this place. So by a single click, we are able to generate documents also for this one. Okay, so again, I just need to go in file, export. So in export, multiple other options has been given. So we can choose out what options is needed. Okay, so this is the one thing that like similar smaller problems we have solved in this one. What we could do with this one, we can do some kind of animation also in this MUPAT sessions. So like I just take a look which problem I have. Okay, so what I have this simple pendulum problem with this one. So in which what we have did, we have put it some kind of external links also, some of the external images, some text has been defined. So it's a simple pendulum problem in which we have written each and every equation. So we have defined that th will be treated as symbol theta. We have defined that f is equals to ma, where a is equals to minus of g of sine theta t, and so on. So complete equations we have assigned in this plan. And here we are solving that numeric ODE and plotting that oscillations of that simple pendulum. And below what we are doing, we are just creating some kind of animation. So what I do, I just execute and then we can discuss further. So solving, graphics as well as animation, all things are possible. But when we are going to export this as a PDF or HTML file, it will never export that animation.
See, MUPAT is only for the symbolic computation.
Symbolic computation.
And there is no link between the MATLAB function and
No, it is there. I'm coming about that also. So like your concern is that whenever we are working on MATLAB scripts, I need to call some of the symbolic computation and simulate that symbolic computation.
You have to write SYMS.
SYMS is the one option that, but might be I have some bigger equations. First I go and solve in that this MUPAT prompt, and then I need to convert as a MATLAB code and use that.
How you will convert into MATLAB?
I show you. So meanwhile it is
Simple example. You just take a linear equation. For example, x plus y is equal to.
okay.
So how you will convert?
So should I take simply a quadratic equation and show that simple linear equation? X plus y is equals to 0. Okay, so let it be complete. I just show you. I don't know what happened to my system at that sudden. It is taking quite longer time to do, but fine. So while it is going to simulate, we can see that what we could do with symbolic math. So this we have already seen that sims abcx a function of ax square plus bx plus c, and then solve will do it for us. Where we can use in academia this symbolic math toolbox. So mathematics department, so for their foundation courses, calculus, differential equations, linear algebra, advanced courses of number theory, advanced algebra. So everywhere we can use. In engineering departments like mechanical, where system dynamics, heat transfer methods, fluid dynamics will be taught, we can use over there. Electrical, circuit analysis, signals and systems, civil, solid mechanics and structural analysis, physics, mechanics, optics, electromagnetics, life sciences, bioinformatics, computational biology and system biology. So everywhere we can use.
Number theory with the some calculation quantity से use कर सकते हैं. Calculation के use कर सकते हैं. उसमें तो symbolic क्या कर सकते हैं?
Now, number theory, like we can use for like different union, merging and all those stuffs also is available. So we can use over there. So different symbolic math libraries. So libraries of like calculus, solving different equations, integral and z transform, simplification problems, linear algebra problems, special functions. So like Bernoulli, Bessel, beta, and so on. Function, sine, cosine, integral, gamma. So all those things are available, and plotting also 2D, 3D, and animation, which we are going to view. Okay, so this has been executed. Now it is showing that oscillations. So best thing is that like you are teaching to your students and you want to show a practical thing also, which we can going to take place in the lab itself. So you can show that changing different values, whenever the value is this much, what will be the result? If I change gravity with this value, what will be the oscillations of that simple pendulum? So you can show with this curves also, or by this animation. Like if I click on this animation, it will start oscillating. Okay, so it totally depends that how you are going to use this. Okay, so here we have defined all those parameters, that mass should be 1, length should be 1, so we treat it as a 1 kilogram and 1 gram or 1 meter and 9.8, whatever it is. And so initial conditions, pi by 6 and 0 has been initial conditions. For that, this oscillation has been come up. Now, so your question that how we are going to convert as a MATLAB script. So MATLAB script directly is not possible. Okay, one thing. From 16A onwards, we can convert as a live script. Earlier, what is the command? So if I go in documentation and I just navigate to Symbolic Math Toolbox, sorry. Symbolic Math Toolbox and this integration. So MUPAT code conversion. So this is the newly added function is there, convert MUPAT notebook into live script. So what is live script? I'll let you know that also. Earlier this function is there, generate MATLAB. So like how we are going to use this one? So it is convert line by line thing for me. So like here it says that print unquoted generate code MATLAB. So this is a function basically, and x square plus y cube, y by 3 plus 1 by 6 as this equation. So earlier it is going to, if you are using version prior to 16A, even 15B also, it is going to generate like this only. But if we have a 16A or 16B versions, so it is going to convert a complete MUPAT notebook.
In MUPAT, what are the commands by which we can convert a particular function into MATLAB?
So this is the only command. This is the only command.
No, see, I am using MUPAT and I have opened this. Now I have just y is equal to x square. Now I want to.
You have y is equals to x square equation has been written. Now in below line you must write this command: print unquoted generate MATLAB and your y in this place. So like what I do, I also could do so that other can see that thing. So I'm opening a new MUPAT book in which I have written y is equals to x square. Okay. Okay, so it has said that y is equals to x square is there. Now what I simply write down that print unquoted comma, the same command which has been written, which has been written in this place. So unquoted comma generate double colon MATLAB and my function name. So I say that generate double colon MATLAB, and in this case I'm just going to write it down as y and close it. So unquoted T0 is equals to y, and it has this much. So it is showing that equivalent MATLAB command in this place also. Like here also, if we need to write down, so we can write it like this also: y is equals to x square directly in this place also. So it is showing that unquoted y is equals to x square. Because of we haven't used any function in this place. If we are going to use up some function, like here in these examples, they have shown that matrix of 1 0 0 0 0 1 So generate A. So it is showing that A is equals to reshape. So command, equivalent command in MATLAB has been shown.
So what is the MATLAB function for y is equal to x?
So it's simply y is equals to x square. In MATLAB also we can write like this. In MATLAB also, but we require value of x.
For example, x to the power 1 by 2. Yeah. Then
So those all will be written in MATLAB also in similar fashion. If something which is not written in, it can be written in Symbolic, but it cannot be written in MATLAB, so it will generate that equivalent command. Like here, normally we write matrix in MATLAB. In MATLAB, whenever we are writing some kind of matrix in MATLAB, we use these square braces. Say 1 space 0 space 0, and in for second line we again write it down that one say 0 space 1. So this is my matrix will become. But in symbolic math we cannot write like this. In symbolic math we have to write like this: A colon equal matrix y comma 0 comma 0, again 0 comma 0 comma 1. So it is, we are defining that content of first row, content of second row, so that it can generate a matrix for me. Now here we have written that how we can write it down as a MATLAB code. So what it did, it generated this code reshape. So it taken all the contents 1 0 0 0 0 1 in this place and say that it should be a 2 cross 3 because of we have 2 rows and 3 columns. Similarly, like an array.
For linear programming, the same if we write in this new page, this can be converted into
MATLAB code. But if you are using newer versions, it is quite
in 2010 it is
okay. So no problem. I will let you know so that you are aware about that. So like I have used this introduction one, this one. This MuPad file is there. What I need to convert as a MATLAB code. So I have already shown you this one command in this place, that convert MuPad notebook. This is the one option. Other option is that we can directly go in this place, right click on my MuPad file. It shows that open as live script. So what is live script? I will let you know when it opens. Advanced version 16 and 16B only, because of live script has been launched from 16A versions. So I say that open as live script. So what it will do now, it will launch a MATLAB file with that symbolic math computation commands. So it automatically taken that sim x. We haven't defined in that in this file any of these symbols, but it has taken in this place at sims x figure, automatically added this figure command, plot f, solve f, because of in MATLAB equal symbol will be treated as double equal sign. Over there equal symbol, single equal will treat as a equality symbol. Okay, sim 0. So we are converting this as also as a symbol x. So automatically it has done for you.
Assigning value, we are using single equal sign.
See, no, in MATLAB assigning value will be treated as single value, single equal sign.
Single equal sign.
In MATLAB.
In MATLAB, okay.
Equating, we require two equal symbols. In symbolic computations, what we require? We require for defining that something is equal to a variable, colon equal, assigning
to colon.
Colon equal, and to equating we use single equal. Okay, so for floating it automatically says that VPA, so automatically it has converted. Now best part of this live script, that in normal MATLAB script, like whenever we are solving these kind of scripts, it will show that those results on command window or on a separate figure. But whenever we have live script, we can run it and it will show in same window my outputs of command window as well as that figures. You see, right now it's showing that in this place. Okay. Just run option has been given. run all. So it has that all the options has been, all the answers has been shown in the same window. So like in earlier MATLAB, whenever we need to write down some of the text, we must need to put up as a comment section. Here what we have different sections has been given. So what I require a code or I require a text. So like below I need some kind of, so in this place, I need to insert some kind of text. So I can start writing some of the text. I don't need to put a single percentage line. Like this is and the cell option is always available. Like we can execute specific area of my code and see that what is the result of that particular section. So it is showing that result of this section is this. Sorry. Okay, so any question? Yes, please. Okay, so any question from centers? Real life. MuPad, basically MuPad is an engine name. So they have given the GUI name as a MuPad. So what happened that earlier MATLAB has a Symbolic Mat Toolbox from way back version 5s, but up to 2007 versions, they are using Maple as an engine of symbolic computation. In 2008, they have developed their own engine, which is known as MuPad, and they incorporate into MATLAB. And now we are using the same engine. So they are going to enhance that in each and every release. So whoever is using 7. Or 2007 releases, they are able to see that one more tool along with Symbolic Mat Toolbox, extended Symbolic Mat tool. Without that, it cannot run.
One Mathematica is also used for symbolic.
Yes, it is a completely symbolic computation tool.
No, nowadays they have extended for numerical computation.
So that is possible, but their base is totally a symbolic computation. Any other questions?
Yes, sir.
Yes, please.
My question. Hello.
Yes.
Sir, my question is how we can solve ANOVA problem using MATLAB. Can you give any
ANOVA
example?
problem using MATLAB. So you require statistics and machine learning toolbox for that.
Okay.
So for that, directly this command has been given, ANOVA. So it is available in statistics and machine learning toolbox. Is this okay? Any other question? Okay. Thank you.
Thank you, sir. Thank you.
Should I disconnect?
So those who are interested in in simplex method. Because some of the participants have requested for simplex method. So after tea, we will discuss 15 to 20 minutes on simplex method, and that will be clear.
Should I close this?
Those who are interested,
Sir, just a minute.
stay here.
No problem.
Okay, and
The centers will not be there.
at all the nodal centers, we are going to have a tea break, and after tea break, we have a session on.
Okay.
We have a session on simplex.
Simplex.
We have a session on simplex method. If those centers are interested, they can continue with us. Otherwise, they can disconnect and leave. Okay. Thank you.
Should I stop sharing?
Thanks.
बाकी सब तो बैठे हैं।
So, linear programming problem, when there are up to two variables, then we use the graphical. More than two variables, we need to use the simplex. So before that, before we come to the simplex method, we have some definitions related to the solution and basic principles. For example, this is our LPP. And this is our given LPP of two variables, but we want to solve it by simplex. We can have also the LPP of three variables or more than three variables, but in order to understand in a simpler manner, we take it as for two variables. Right? So before that, we have some definitions. First is solution of a LPP. Second, feasible solution. Third, basic feasible solution. Basic solution, then basic feasible solution.
1-6.
Fourth is basic feasible solution, and fifth is optimum solution. पांच तरह के डिफरेंट टर्म्स अपन जो है देखते हैं कि दिस इज योर सॉल्यूशन, बेसिक सॉल्यूशन, ये एग्जैक्टली है क्या? फर्स्ट इज सॉल्यूशन टू एलपीपी. सॉल्यूशन टू एलपीपी मींस एनी सेट ऑफ वैल्यूज विच सेटिस्फाई ओनली दिस कंस्ट्रेंट. इसको तीन पार्ट्स में डिवाइड कर रहे हैं. ए, दिस इज ऑब्जेक्टिव फंक्शन, बी आर द कंस्ट्रेंट, सी इज द सेट ऑफ नॉन नेगेटिव सीरीज. सो एनी सेट ऑफ वैल्यूज विच सेटिस्फाई ओनली A is called solution. अपना टारगेट ऑप्टिमम तक पहुंचना है, right? Solution means any set of values which satisfy only B part, not A. Sorry, only set of constant. मान लीजिए x is equal to -100 and y x2 is equal to -10,000. It is also a solution. कोई भी ऐसी वैल्यू जो B पार्ट को सेटिस्फाई करती है, that is your solution. But we are not interested. अभी तो हमने B को ही कंसिडर किया है. अब दूसरी क्या बात आती है? feasible solution. Feasible solution means the solution which is feasible, which also satisfy the non-negativity restriction. It means which satisfy B and C. It is called feasible solution. The set of values which satisfy the set of constant as well as non-negativity restriction is called feasible solution. ये बेसिक टर्मिनोलॉजी इसलिए बता रहे हैं क्योंकि ये बार-बार यूज होगी, है ना? Then we come to the basic solution. ये बात क्लियर होगी. अब because we don't have any tool to deal with the inequality. Inequality को solve करने के लिए graphical के अलावा कोई तरीका नहीं है. And our basic जो computational है, deal with the system of equation. We can solve the system of equation. So it is very necessary to convert this set of inequality into set of equations. For that purpose, we use the surplus and slack variables. Right? तो इसके लिए इस सिस्टम ऑफ इक्वेशन को में कन्वर्ट करने के लिए मैं x1 प्लस x2 लेस देन 5 है, इसमें मैं ऐड कर रहा हूं x3 स्लैक वेरिएबल, बिकॉज सिंप्लेक्स मेथड इज आल्सो बेस्ड ऑन सिस्टम ऑफ इक्वेशन को डील करता है। ऐसा नहीं है कि सिस्टम ऑफ इनइक्वालिटी को कोई सॉल्व कर सकता है। सिस्टम ऑफ इनइक्वालिटी इज रिप्रेजेंटिंग द रीजन, सिस्टम ऑफ इक्वेशन को सॉल्व किया जा सकता है। So it is necessary to convert this set of inequalities into set of equation. For that purpose we use the slack and surplus variable. यहाँ पे less than inequality है, for that purpose we add the slack variable. अगर greater than होता तो उसमें minus surplus variable, minus x3 या x4, दोनों less than constant है, तो इसमें system of equation में x4 ऐड किया, x4 is also slack variable, right? इस सिस्टम ऑफ इनइक्वालिटी को सिस्टम ऑफ इक्वेशन में कन्वर्ट करना जरूरी है, ठीक है। इसी क्वेश्चन को अपन ग्रेटर देन के लिए भी करेंगे, सेम क्वेश्चन बिल्कुल इजी है। नाउ वी कम टू द आवर बेसिक सॉल्यूशन, डेफिनेशन ऑफ बेसिक सॉल्यूशन, एंड ऑल वेरिएबल्स आर ग्रेटर देन इक्वल्स टू 0. x3 and x4 are select variables. Now see, basic solution is the solution obtained by putting sum of the variable equals to 0. यहाँ पे कितने वेरिएबल्स हैं? 4. कितनी इक्वेशन है? 2 हैं। फंडामेंटल थ्योरम ऑफ इक्वेशंस कहता है कि नंबर ऑफ इक्वेशंस इज इक्वल टू नंबर ऑफ वेरिएबल्स, देन वी कैन हैव अ यूनिक सॉल्यूशन इफ द डिटरमिनेंट वैल्यू ऑफ कोएफिशिएंट्स इज नॉन जीरो, राइट। यहाँ पे तो 4 है, इक्वेशन है कितनी है? 2 है, तो कुछ वेरिएबल को 0 मानना पड़ेगा। द सॉल्यूशन ऑब्टेन बाय पुटिंग, फॉर एग्जांपल यहाँ पे n नंबर ऑफ वेरिएबल्स हैं, m नंबर ऑफ इक्वेशंस हैं, तो n माइनस m नंबर ऑफ वेरिएबल्स को 0 लाने पे जो सॉल्यूशन होगा, प्रोवाइडेड द डिटरमिनेंट ऑफ रिमेनिंग वेरिएबल इज नॉन जीरो, इट्स कॉल्ड द बेसिक सॉल्यूशन। इस केस में देखिए कितने वेरिएबल हैं? 4 इक्वेशन है कितनी है? 2, तो 2 को 0 माने। 2 को 0 मानने के लिए अपन क्या करते हैं? इनिशियली जो गिवन वेरिएबल हैं उनको 0 मानते हैं। एक सॉल्यूशन ये है। 2 0 कौन कौन से मान सकते हैं? एक तरीका तो ये हो सकता है x1 को 0 मानो, x2 को 0 मानो। दूसरा तरीका x1 को 0, x3 को 0, C x1 0, x4 0, x2 0, x3 0, इस तरीके से x2 0, x4 0, x1 x2 x3, आपके पास ये टोटल 6 कॉम्बिनेशन है, क्योंकि 4 में से 2 को सिलेक्ट करना है। इट हैज 4C2, राइट। So all these are basic solutions. These are basic solution. Basic solution means solution obtained by putting n minus m variables 0. Right? ये basic solution. सिंप्लेक्स मेथड इज बेस्ड ऑन द सिस्टम ऑफ इक्वेशंस। ये बात आप हमेशा ध्यान रखेंगे कि सिंप्लेक्स मेथड कोई इट इज बेस्ड ऑन द सिस्टम ऑफ इक्वेशंस। इट इज नॉट लाइक कि इनइक्वालिटी को ही वो डील करे, नो, इट मस्ट बी कन्वर्टेड इनटू सिस्टम ऑफ इक्वेशंस। सो बेसिक सॉल्यूशन मींस द सॉल्यूशन ऑब्टेन बाय पुटिंग n minus m वेरिएबल इक्वल्स टू 0। तो यहाँ पे आपने 2 वेरिएबल को 0 किया, तो x को और y को 0 किया, तो फर्स्ट सॉल्यूशन आया x3 इक्वल टू 5, x4 1, x1 और x3 को 0 किया तो x2 आएगा 5, x2 5 है, तो ये कितना हो गया? -10, ठीक है। -10 ये हो गया, इधर चला जाएगा, तो x4 कितना हो गया? 11। x1 और x4 0 है, तो x2 कितना हो जाएगा? -12। x2 -12 है, x1 0 है, तो ये x3 हो जाएगा 5/2, 11/2। ये सारे बेसिक सॉल्यूशंस, राइट? बट now we come to the basic feasible solution, the solution which is basic solution and which also satisfies the non-negative restriction. Basic के साथ feasible भी हो. Feasibility means it satisfies the non-negativity restriction. So basic solution which satisfy non-negative restriction C. ये सारे बेसिक सॉल्यूशंस हैं. The total number of basic solution will be NCM, but all basic solutions are not feasible. आप देखोगे this solution is basic feasible solution because all the values are. Second solution is also basic feasible solution. Third solution is not basic feasible solution because one of the value is minus half. It is only basic solution. ठीक है? अब लास्ट जो डेफिनेशन है that is optimum solution. Optimum solution means वो basic feasible solution, the basic feasible solution which maximize or minimize objective function. Is called optimum solution. अपना टारगेट यहां तक पहुंचना है. उस टारगेट ऑप्टिमम सॉल्यूशन क्या है? ऑप्टिमम सॉल्यूशन इज बेसिक फिजिबल सॉल्यूशन विच, यानी कि अभी तक अपन इन दोनों पे फोकस थे, इन दोनों से बेसिक फिजिबल निकाला. द बेसिक फिजिबल सॉल्यूशन विच मैक्सिमाइज और मिनिमाइज ऑब्जेक्टिव फंक्शन विल बी द ऑप्टिमम सॉल्यूशन. तो जब आप एलपीपी सॉल्व करते हैं ग्राफिकल में, सो द ग्राफिकल रीजन के जो कॉर्नर्स आते हैं दे एक्चुअली रिप्रेजेंट द बेसिक फिजिबल सॉल्यूशन. बेसिक फिजिबल सॉल्यूशन आर रिप्रेजेंटेड, और उनमें से भी वो बेसिक फिजिबल सॉल्यूशन जो ऑब्जेक्टिव फंक्शन की मैक्सिमम वैल्यू देता है, इट इज द ऑप्टिमम सॉल्यूशन. तभी आप उनको चेक करते हैं. तो ये थ्योरी है, वेल दिस थ्योरेटिकल पार्ट, बट वी मस्ट नो व्हाट इज द बेसिक फिजिबल सॉल्यूशन. ठीक है? एंड सिंपलेक्स मेथड इज बेस्ड ऑन इनिशियल बेसिक फिजिबल सॉल्यूशन फाइंड आउट करना पड़ेगा, एंड बाय टेबल वी इंप्रूव द सॉल्यूशन, and we, after finite number of iterations, we find the optimal solution. That is the process, right? Okay, यहाँ तक कोई दिक्कत नहीं है? Any problem? So now we solve the same problem with simplex method. Now I want to solve this. So in first step, simplex method की, because the simplex method works towards minimization, it never works for the minimization. Simplex method में जो tables बनती है वो हमेशा objective function को maximum की ओर ले जाने का काम करती है. तो एक start करने के लिए सबसे पहले your LPP must be in standard form. LPP must be in standard form. Standard form means what? Standard form means your problem must be of maximization type. And second, all the values, all the parameters on the right hand side of constraints must be positive. These two are important in context of simplex method. Your problem must be of standard form. In context of simplex method, your standard form is your problem must be of maximization problem. अगर problem maximization की नहीं है, you convert it into मैक्सिमाइजेशन प्रॉब्लम बाय जस्ट मल्टीप्लाइंग इट विद माइनस 1, या अगर मिनिमम होता तो आप -1 से लेते, बट सर वी आर टेकिंग
ओनली वी हैव टू मल्टीप्लाई विद ऑब्जेक्टिव फंक्शन।
यस,
कंस्ट्रेंट को नहीं करना है।
नहीं, कंस्ट्रेंट ऑफ मैक्सिमाइजेशन टाइप मींस योर ऑब्जेक्टिव फंक्शन मस्ट बी मैक्सिमम।
यार टॉप सपोज मिनिमाइजिंग के है तो क्या करना है,
उसको मैक्सिमाइजेशन में कन्वर्ट
ऑब्जेक्टिव फंक्शन को।
यस, ओनली ऑब्जेक्टिव, यस, you need to convert maximization type problem means your objective function must be of maximization. Second is all the parameter on the right hand side of the constants must be positive, यानी ये जो constants हैं 5 और 1 ये दोनों पॉजिटिव होने चाहिए, that must be positive। यहां देखेंगे 5 भी पॉजिटिव, अगर यहाँ -5 होता या -1 होता इसमें, देन अगेन इसको पॉजिटिव बनाना पड़ता, दोनों तरफ माइनस से मल्टीप्लाई करना। हाँ, ये मान लेते हैं नेगेटिव है
और प्रॉब्लम है मिनिमाइजेशन।
हाँ, देखिए चाहे प्रॉब्लम मिनिमाइजेशन की हो आपको, लेकिन प्रोसेस वही रहेगा। प्रॉब्लम मिनिमाइजेशन की है या सारे कंस्टेंट ग्रेटर देन है, कुछ इक्वल टू साइन है, दैट
मिनिमाइजेशन का प्रॉब्लम है तो उसको मल्टीप्लाई करना पड़ेगा।
हाँ,
मल्टीप्लाई करने के कंस्ट्रेंट को नहीं मल्टीप्लाई करना,
नहीं कंस्टेंट,
सिर्फ ऑब्जेक्टिव फंक्शन,
केवल ऑब्जेक्ट। या मैक्सिमाइजेशन का मतलब है योर ऑब्जेक्टिव फंक्शन, मैं ये लिख देता हूं, मस्ट बी ऑफ मैक्सिमाइजेशन। देयर इज नो रिलेशनशिप, कंस्टेंट कुछ भी हो सकता है, एंड कंस्टेंट भी कुछ भी लेस देन और ग्रेटर देन साइन हो, दैट इज इमैटेरियल, ओनली द पैरामीटर शुड मस्ट बी पॉजिटिव। जो राइट हैंड साइड में जो बी पार्ट है, बी दैट इज रिक्वायरमेंट मैट्रिक्स, दैट मस्ट बी पॉजिटिव। तो यहां पे देखेंगे 5 और 1 ऑलरेडी पॉजिटिव लिया है एज ए सिंपल केस, राइट, तो इट इज पॉजिटिव। अगर ये माइनस होता तो दोनों तरफ माइनस से मल्टीप्लाई, तो माइनस से मल्टीप्लाई करेंगे तो लेस देन साइन ग्रेटर देन साइन में कन्वर्ट हो जाएगा, ठीक है। तो ये दोनों ही क्राइटेरिया सेटिस्फाई कर रहा है, यानी स्टेप फर्स्ट में आप क्लियर। इंट्रोड्यूस slack and surplus variable। इस सिस्टम ऑफ इक्वेशन इनइक्वालिटीज को सिस्टम ऑफ इक्वेशन में कन्वर्ट करना जरूरी है, बिकॉज सिंप्लेक्स मेथड वर्क ऑन सिस्टम ऑफ इक्वेशंस नॉट सिस्टम ऑफ इनइक्वालिटी। तो सिस्टम ऑफ इनइक्वालिटी है, इसको सिस्टम ऑफ इक्वेशन में कन्वर्ट करने के लिए स्लैक या फिर सरप्लस वेरिएबल ऐड या सब्ट्रैक्ट करना पड़ेगा। तो यहां पर हम देखेंगे x1 प्लस x2 लेस देन 5, इसमें मैं एक सिलेक्ट वेरिएबल ऐड कर रहा हूं x3, इट इज 3x1, इसमें भी एक सिलेक्ट वेरिएबल ऐड हुआ है x4 1, एंड ऑल these are select variable। एक नेक्स्ट एग्जांपल और लेंगे जिसमें सरप्लस भी होगा, ठीक है, तब अपन ये स्टेप्स आपकी कॉमन रहेगी। these are select variable x3 एंड x4। अब देखिए सिस्टम ऑफ इक्वेशन लग रहा है, 4 वेरिएबल है, 2 इक्वेशन है। थर्ड स्टेप, टू ऑब्टेन इनिशियल बेसिक फिजिबल solution। Simplex method is a iterative process in which we first have initial basic feasible solution and then by table we improve it up to optimal solution। यानी इसमें पहला initial basic feasible solution आप देंगे, आप फाइंड आउट करेंगे, राइट। अब देखो बेसिक फिजिबल सॉल्यूशन मैंने बताया था, कुछ वेरिएबल को 0 रखेंगे तो जो सॉल्यूशन आएगा दैट विल बी बेसिक सॉल्यूशन, उनमें से जो पॉजिटिव वैल्यू देगा वो बेसिक फिजिबल सॉल्यूशन। तो इनिशियली यहाँ पे देखिए टोटल कितने वेरिएबल है, 4, इक्वेशन कितनी है, 2 को 0 रखना पड़ेगा. Initially, as a our convenience, we take origin as a solution. क्योंकि किसी भी LPP में origin एक solution हो सकता है. तो we are अब 4 में से 2 को 0 रखना है, कुछ भी रख सकते हैं. But as a reference point, x1 x2 को हम 0 मानते हैं. क्योंकि क्या होगा? If we put x1 0, x2 0, x3 is 5, 1. ये solution आ गया. You can take any of the values too, but we are not familiar. We are not, हमें पता नहीं है किसकी वैल्यू 0 रखें या किसकी. तो as a reference point, as a starting point, we take 0 0 as a solution. x1 x2 0 रखा, x3 5 आया, x4 1 आया. It is your initial बेसिक फिजिबल सॉल्यूशन. बेसिक भी है, कुछ वेरिएबल को 0 रखने पे है. फिजिबल भी आप चेक कर सकते हैं. बेसिक फिजिबल सॉल्यूशन. क्लियर? अब ये जो सरप्लस वेरिएबल है, इट कंट्रीब्यूट नथिंग इन द ऑब्जेक्टिव फंक्शन. इसकी जो कॉस्ट है वो 0 रखते हैं, बिकॉज दीज आर ओनली यूज्ड टू कन्वर्ट सिस्टम ऑफ इनइक्वालिटीज इनटू सिस्टम ऑफ इक्वेशंस. तो x z में ऑब्जेक्टिव फंक्शन में x3 और x4 को रिप्रेजेंट करने के लिए 0 इंटू x3 प्लस 0 इंटू 4. ये जो कांस्टेंट है 1 इंटू x1 2 x2, दीज आर कोस्ट मैट्रिक्स. कोस्ट कोएफिशिएंट. यस, ये आगे अपने टेबल में यूज है. यहां तक क्लियर है? ये 3 स्टेप्स हर एक एलपीपी में काम आएंगे, चाहे वो ग्रेटर देन हो, मिनिमाइजेशन हो, एवरेज. इनिशियल बेसिक फिजिबल सॉल्यूशन आपको फाइंड आउट करके देना पड़ेगा, देन ओनली यू कैन अप्लाई द टेबल. क्लियर? बेसिक फिजिबल सॉल्यूशन. बेसिक मींस कुछ वेरिएबल को 0 रखें. फिजिबल मींस अब आप देखेंगे दिस इज द आइडियल बेसिक फिजिबल सॉल्यूशन. बेसिक भी है, फिजिबल भी है, सॉल्यूशन भी है. सॉल्यूशन मींस इस सेट ऑफ कंस्ट्रेंट को सेटिस्फाई करने वाला. फिजिबल मींस नॉन नेगेटिव रिस्ट्रिक्शन को. बेसिक मींस किन्हीं वेरिएबल को 0 रखने पे जो है, दैट इज बेसिक. These 3 steps are very important. If you are good at this, आगे zj माइनस cj करना हो, everybody knows. वो आप एक फिक्स प्रोसीजर रहता है. बट इसमें अगर कहीं गड़बड़ है, फंडा यहां से ही क्लियर. अदरवाइज कोई जरूरी नहीं है. तो फिर अगर थोड़ी सी भी इसमें अल्टरेशन हुआ नहीं, आप नहीं देख पाओ. ठीक है? एक मिनिमाइजेशन की भी प्रॉब्लम करेंगे अपन, नो डाउट, उसको भी अपन करेंगे. सो इट इज ओके. नाउ वी कैन गो अहेड. अब अपन स्टेप 4th में जाएंगे. ये जो वेरिएबल्स हैं जिनको 0 रखा, दीज आर कॉल्ड नॉन बेसिक वेरिएबल. जिनकी वैल्यू नॉन 0 आई है, दीज आर कॉल्ड बेसिक वेरिएबल. जो जिनको 0 है उनको नॉन बेसिक, जो 0 नहीं है उनको बेसिक. अपने को बेसिक ज्यादा इंपॉर्टेंस वाले. एक टेबुलर फॉर्म में टेबल बनाएंगे. फर्स्ट सिंप्लेक्स टेबल या इनिशियल सिंप्लेक्स टेबल. इस फॉर्मेट में CB XB B CJ X1 X2 X3 X1. ये एक फिक्स फॉर्मेट आपको हमेशा याद रखना है. XB मीन्स बेसिक वेरिएबल. इसको मैं नोटेट कर रहा हूं, बेसिक वेरिएबल. CB मीन्स कॉस्ट ऑफ बेसिक वेरिएबल. CJ is cost, B is for right hand side part, x1 x2 इस पार्ट में कोफिशिएंट मैट्रिक्स आएगा A जो सिस्टम ऑफ इक्वेशन का है। अब आप देखेंगे XB जो है अपने x3 और x4 इनकी कोस्ट क्या है? कोस्ट मीन्स द कोफिशिएंट करस्पॉन्डिंग कोफिशिएंट इन योर ऑब्जेक्टिव फंक्शन दैट इज 0 and 0. B your right hand side 5 1. A is your coefficient matrix this. ये सिस्टम ऑफ इक्वेशन है, ये 1 1 1 0 3 -2 0 1. CG stand for the cost of individual variables. x1 की हाँ किसको? CB is the right hand side part 5 1. जो वैल्यू ऑफ बेसिक वेरिएबल है वो 5 और 1, इनके करस्पॉन्डिंग x3 की वैल्यू 5, x4 की वैल्यू 1. दिस इज B. एंड CZ stand for the cost of variable. ये है 1 2 0 0. आपको एक चीज ध्यान रखनी है, इन each and every table corresponding to basic variable. बेसिक वेरिएबल कौन कौन से? x3 और x4. We must have unit matrix. आप देखेंगे x3 के corresponding 1 0, x4 के corresponding 0 1. Unit matrix है. Clear? Now we calculate the net evolution, that is called ZJ minus CJ. इस सिस्टम ऑफ इक्वेशन को लिखा है इन टेबुलर फॉर्म में। जो सिस्टम ऑफ इक्वेशंस आपने बनाई है ये दो, इसी को ही एज इट इज यहाँ लिखा है, आप देख सकते। ये वाला पार्ट इंपॉर्टेंट है, बेसिक, जिनकी वैल्यू नॉन जीरो आई, ठीक है। देन जेड जे माइनस सी जे फाइंड आउट करेंगे। ZJ minus CJ, exactly ZJ means your CB into XJ ट्रांसपोज। ये ZJ है, इसको थ्योरेटिकली नहीं जाएंगे। ZJ minus CJ का मतलब है हर एक कॉलम को करस्पॉन्डिंगली CB से मल्टीप्लाई करेंगे। जैसे फर्स्ट रो है, फर्स्ट कॉलम है, इसके करस्पॉन्डिंग ZJ minus CJ फाइंड आउट करेंगे। ZJ होता है CB मल्टीप्लाइड बाय XJ। CB इज लाइक दिस, ये 0 0 है, इसका ट्रांसपोज लेंगे तो 0 0, और फर्स्ट कॉलम जो है आपका 1 3, गुणा करेंगे तो 0 आएगा। और ये नहीं देख करके हम बच्चों को बताते हैं डायरेक्ट कि इसको 1 को 0 से मल्टीप्लाई करो, प्लस 3 को 0 से मल्टीप्लाई करो, टोटल कितना हुआ 0, माइनस CJ जो ऊपर लिखा है 1, इट विल बी ZJ माइनस CJ इज -1। Similarly for second column, 1 into 0 plus 0 into -2, total कितना हुआ 0, 0 minus CJ is 2 -2, and corresponding to basic variable ZJ minus CJ will be always 0. 1 into 0 plus 0 into 0, 0 minus 0 is 0. You can verify. इसके करस्पॉन्डिंग जो यूनिट मैट्रिक्स, उसके करस्पॉन्डिंग ZJ माइनस CJ विल बी ऑलवेज 0. Then you have calculate ZJ minus CJ. Now according to the procedure of simplex, we take the most negative ZJ minus CJ. Most negative is -2. It means it is the entering vector. अब ये बेसिक बनना चाह रहा है, इट इज एंट्रिंग वेक्टर। इसको मैं एरो से शो कर रहा हूं, एंट्रिंग वेक्टर, बट जगह तो दो ही है, दो की है। इट इज एंट्रिंग वेक्टर, इट मींस वन वेक्टर विल आल्सो बी डिपार्टिंग वेक्टर। सो फॉर दिस वी टेक minimum ratio of this column, x2 column element and corresponding to B. इसके लिए मैंने आपको बताया था मिनिमम ऑफ बी अपॉन xij, योर xij मस्ट बी ग्रेटर देन 0। ये एंटरिंग वेक्टर है, इसके कॉलम के एलिमेंट्स का बी के एलिमेंट से करस्पॉन्डिंगली रेशियो फाइंड आउट करें। इसके कॉलम के एलिमेंट्स का बी के करस्पॉन्डिंगली एलिमेंट से रेशियो फाइंड आउट करेंगे। तो यहाँ पे है बी और केवल उन्हीं का लेंगे जो पॉजिटिव हैं। 5 इसके सामने 1 अपॉन 1, 1 अपॉन -2 नहीं लेंगे बिकॉज इट शुड बी पॉजिटिव, सो ओनली देयर इज अ 1 एलिमेंट और यही आपका मिनिमम होगा। एंड फॉर जिसके लिए मिनिमम है दिस इज कॉल्ड की एलिमेंट। एंड इसके सामने जो वेरिएबल है बेसिस में कौन है? x3। x3 विल बी आउटगोइंग वेक्टर। This is the take Zj minus Cj most negative will be entering vector. Calculate the minimum ratio. Where the minimum ratio is there, it is key element, and corresponding vector in the basis is the outgoing vector. Most negative Zj minus Cj is entering vector. Then find the minimum ratio. Where the minimum ratio is there, it is key element, and corresponding vector in the basis will be the outgoing. राइट अब वापस टेबल नहीं बनाएंगे। सी बी एक्स बी बी फॉर्मेट वही रहेगा x1 x2 x3 x4। कहाँ चेंज होगा? बेसिस में। बेसिस में पहले थे x3 और x4, अब अपन x3 की जगह किसको ला रहे हैं? x2 और x4। x2 की कॉस्ट कितनी है? 2 और x4 की 0। आप कॉस्ट ये 1 2 0 0। Clear? Isn't it? Now, as we know, corresponding to basis element, there will be unit matrix. Unit matrix देखिए x3 और x4 के लिए भी बन रहा था। इसका मतलब x2 के लिए 1 0 और x4 के लिए 0 1 आना चाहिए। एंड उसके लिए अपन की एलिमेंट का यूज करेंगे। अब देखिए जो भी की एलिमेंट है उसको उसी के एलिमेंट से डिवाइड करें। यानी आपको यहाँ 1 चाहिए तो इट इज द 1, तो की एलिमेंट वाली रो एज इट इज रहेगी 5 1 1 1 0। नाउ आई वांट टू मेक दिस एज ए 0। -2 को मुझे 0 बनाना है यूजिंग द की एलिमेंट। ओनली मल्टीप्लिकेशन, all multiplication and division will be key element row, then only you can add and subtract to another row। ये क्राइटेरिया है कि इसको 0 बनाना है तो इस की एलिमेंट वाली रो यानी R1, इसको 1 बनाना था, आपने एज इट इज लिख दिया। नाउ आई वांट टू मेक -2 0 and the condition is all the multiplication and division will be your first row and then only you can add or subtract into another row। ऐसा नहीं कि -2 को 0 बनने के लिए पूरी रो को 0 से मल्टीप्लाई कर दो 0 बन जाएगा। No, right? It means we have to use the key element row. All the multiplication and division must be with key element row, and then you can add or subtract into another row। Now, what we can do? बताइए क्या कर सकते हैं? It means R1 को 2 से मल्टीप्लाई करें, then R2 में ऐड कर लें, तो R2 में ऑपरेशन करेंगे R2 plus 2R1 0 आ जाएगा। पूरी रो के साथ करेंगे R2 into 2 that is 10, 10 plus 1 11. 1 into 2, 2 plus 3, 5, 0, 2, 1. अब देखिए, basic element is x2 and x4. Corresponding to x2 it is 1, 0. Corresponding to x4 it is 0. पहले आपने x3, x1 और x2 को 0 माना था ना शुरू में. अब देखो x2 आ गया अंदर. इसका मतलब x2 की वैल्यू 5 के बराबर है और x4 की वैल्यू 4 के बराबर है. आपने बेसिक फिजिबल सॉल्यूशन की लिस्ट बनाई थी. एक शुरुआती सॉल्यूशन था x1 x2 0, देन x3 x4, वो अपन ने चूज किया था. अब ये सेकंड बेसिक फिजिबल आ रहा है. यानी इट इज इटरेटिव प्रोसेस. by table we will improve the basic feasible solution up to optimum solution. ठीक है, लेकिन प्रोसेस ये. अब वापस zj माइनस cj कैलकुलेट करेंगे. zj माइनस cj मीन्स 1 into 2, it means 2. 5 into 0, that is 0. टोटल कितना हुआ? 2 माइनस cj 1, it is equals to 1. 1 into 2, that is 2 plus 0, 2 minus 2, that is 0. It is all unit elements के corresponding zj minus cj will be 0. And 2 into 1 plus 0 into 2, that is 2 minus 0. 2. And this is again unit matrix, basic elements हैं, इसके लिए zj minus cj. All zj minus cj becomes greater than 0. Now stop the simplex method. We have reached at the optimum solution. Since all zj minus cj is greater than 0, so it is optimal solution. This is your optimum solution. अगर इसमें और नेगेटिव आता तो again we will have the same iteration. All zj minus cj becomes positive. It means we have reached at the optimal solution, and the optimal solution is x2 is equal to 5. इसमें x1 नहीं है, x4 है, but x4 is a slack variable. We don't need x1 is जो इसमें नहीं है, it means वो 0 है. So x1 is 0. For z में put करेंगे, z is x1 plus 2x2, that is 10. This is your solution. It was easy question. 2 टेबल में ही हो गया. अदरवाइज इसमें कहीं पे भी कोफिशिएंट्स चेंज होते हैं तो हो सकता है एक टेबल और बनानी पड़ती, 2 टेबल. बट फॉर 2 वेरिएबल्स यू कैन इमेजिन मैक्सिमम 6 नंबर ऑफ टेबल से ज्यादा नहीं हो सकती, क्योंकि प्लस माइनस को भी आप कर लो तो कितने इक्वेशन. सो दिस इज द सॉल्यूशन. ओनली द चेंज इज if there is a greater than sign, we will subtract surplus variable, and then we will find the we will add the artificial variables. So this is the fixed process to obtain optimal solution for algebra. Clear? अब एक different question करते हैं इसी का, greater than sign. अपना क्वेश्चन था मैक्सिमम, मैं अब मिनिमम केस ले रहा हूं. मिनिमाइज जेड इज इक्वल टू x1 प्लस x2, x1 प्लस 2x2 सब्जेक्ट टू, क्या बता सकते हैं क्या था? x1 प्लस x2 ग्रेटर देन, एंड दूसरा
3x1 minus 2x2 greater than equal to
1. Now we have taken a totally opposite problem. It is of minimization and all the constraints are greater. So same way, your step 1 is LPP must be in standard form. Standard form is your problem must be of maximization problem, and all the elements on the right hand side of the constraint must be positive, right? अब इसमें first thing is that your problem is of minimization type, so you must convert, because simplex table works towards maximization, it never works towards minimization. तो मिनिमाइजेशन में पूरा प्रोसेस ही उल्टा करना पड़ेगा। तो अपन मैक्सिमाइजेशन की बात करेंगे, तो मैक्सिमाइजेशन प्रॉब्लम को कन्वर्ट करने के लिए जेड डैश एक नया ऑब्जेक्टिव बनाया, दैट इज इक्वल्स टू माइनस जेड, और माइनस से मल्टीप्लाई कर दिया, दिस बिकम मैक्सिमाइजेशन ऑफ जेड डैश, राइट? ओके, देन राइट हैंड साइड एलिमेंट्स इज 5 1 1, ऑल आर पॉजिटिव, लेस देन ग्रेटर देन हो सकता है, इट्स नॉट अ प्रॉब्लम, बट योर एलिमेंट्स ऐसा नहीं हो -5 हो या -1, ऑल आर पॉजिटिव, so there is a no change, subject to x1 plus x2 is greater than 5, 3x1 minus 2x2 greater than 1, x1 x2 greater than 0. This is your step first, right? Step second was introducing slack and surplus variables. Now in this case we will subtract surplus variable. This case may, because all the constants are greater than sign, so your problem is maximize z dash minus x1 minus 2x2 subject to x1 plus x2 minus x3 is equal to 5 and 3x1 minus 2x2 minus x4 is equal to 1, where x1, x2, x3, x4 are greater than 0. Now this x3 and x4 are surplus variable. It is okay? Surplus variable, subtract here, same procedure. First 3 steps will be the same throughout your simplex method. Only slightly change will be there after step 4. ये तो करना ही पड़ेगा, डायरेक्ट नहीं है कुछ भी. Must know what is the basic theory. Third step, to obtain initial basic feasible solution. Again, we have same situation. We have 4 variables, but only 2 linear equations are there. So what we can do? 2 variables को 0 रखें. As a customary, we take origin as a solution. So let x1 is 0, x2 is 0, then x3 is -5 and x4 is -1. Now this is basic feasible solution or not? This is basic feasible solution or not? Yes? This is basic feasible solution or not? Why? Yes, it is basic solution, but feasible solution nahi. It is not basic feasible solution. But simplex method works on basic feasible solution. For using simplex table, you must have initial basic feasible solution. But this is not basic feasible solution because negative में है values. अपनी definition क्या कहती है? Basic भी हो, कुछ variables 0 रख के, feasibility भी हो, means non-negative हो, positive हो. Right? यही. But this is only basic solution, but not feasible. But we need initial basic क्या करें? किससे? System of equation तो यही है. क्या कर सकते हैं? In that case, we introduce a
another variable that is called artificial variable a. यहाँ पे नेगेटिव आ रहा था, we introduce a artificial variable a1. इसमें भी नेगेटिव वैल्यू आ रही, इसमें भी एक वेरिएबल इंट्रोड्यूस किया a2. a1 and a2 are artificial variables. अब कितने वेरिएबल हुए? इक्वेशन कितनी है? इक्वेशंस कितनी है? बोलो बोलो. 2 है. और वेरिएबल कितने हैं? कितने वेरिएबल को 0 रखना चाहिए? 4. तो मैंने क्या किया, जिनकी वैल्यू नेगेटिव थी उसको 0 मान लिया, x1, x2, x3 और x4 चारों को 0 मान लिया. 4 को 0 करना, तो आंसर आया a1 is equal to 5, a2 is equal to 1. This is basic feasible solution or not? Yes. This is basic feasible solution. So these are the artificial variable. When artificial variable is introduced, there are two methods. One is Bingham method and second is the two-phase method. So I will only discuss you the Bingham method. Now this is your objective function. Slack and surplus variable की cost coefficient हमेशा 0 रखती है. It is 0 into x3 plus 0 into x4. Now from we use the big M method. Big M method means अब जो आर्टिफिशियल वेरिएबल ऐड किए हैं उनकी कॉस्ट रखेंगे -m. -m a1, a2 की भी कॉस्ट रखेंगे -m a2, where m is very large quantity tends to infinity. हम चाहते हैं कि आर्टिफिशियल वेरिएबल जल्दी से जल्दी निकले, तो किसी को मैक्सिमाइज करना हो तो उसकी कॉस्ट अगर माइनस में ज्यादा हो तो ऑटोमेटिकली सबसे पहले बाहर निकलेगा. तो इन बिगम मेथड जब आर्टिफिशियल वेरिएबल इन्वॉल्व है, देन देयर आर टू मेथड्स. वन इज द बिगम मेथड एंड सेकंड इज द टू फेज मेथड. फॉर बिगम मेथड वी टेक द कॉस्ट ऑफ आर्टिफिशियल वेरिएबल -m, where m is a very large quantity. Right? अब इसको अपन एज ए टेबुलर फॉर्म में करेंगे. अब आप देखेंगे कि अभी तो बेसिक वेरिएबल कौन कौन से हैं? ये दोनों बेसिक हैं और ये सारे नॉन बेसिक हैं जिनकी वैल्यू 0 आई. सो वी मेक वन टेबल. Your first simplex table. Same way, CB, XB, B, CJ, X1, X2, X3, X4, A1 और A2. CJ is the cost. Cost हो जाएगी -1, -2, 0, 0, -m, -1. This is cost. Cost means the coefficients in the objective functions. XB means basic variable. कौन कौन से basic variable हैं? A1 और A2 जिनकी वैल्यू नॉन जीरो आई है. This is your A1 and A2. What are their cost? Cost of basic variable -m, -m. What is B? B is 5 and 2, 1. In this we will write the coefficient matrix, that is 1, 1, -1, 0, 1, 0, and 3, -2, 0, -1, 0, 1. Corresponding to your artificial variable, we have unit matrix. In each and every question, we must have unit matrix. Again, we calculate Zj minus Cj.
Zj minus Cj same way, 1 into minus m plus 3 into minus m minus 3m. Total is minus 4m minus Cz means minus minus plus 1. This is Zj minus Cj for first column. For second column, it is minus m plus 2m. It is m plus 2. For third, it is m. Fourth, it is m. For this, it is 0 always. So now, which is most negative?
minus 4m.
Minus 4m, because m is a large quantity. कई बार ऐसा भी होता है माइनस 4m प्लस 1 हो और दूसरे में माइनस 4m हो, तो कौन सा मिनिमम होगा? माइनस 4m, क्योंकि उसमें कुछ ऐड नहीं हो रहा. So in this case, the most negative quantity is this, and corresponding to this, this is your entering vector. And for outgoing vector, we will calculate the minimum ratio of this column or this column. Minimum ratio is B upon Xij. Your Xij must be greater than 0. Minimum ratio is 5 upon 1, 1 upon 3. कौन सा होगा? 1 by 3. So it means this is your key element and corresponding vector in basis is A2. A2 will be outgoing. यानी कि इस x1 जो है वो A2 की जगह लेगा, है ना? तो नई टेबल जो बनेगी CB, XB, B, CJ, X1, X2, X3, X4, A1, A2. It is minus 1, minus 2, 0, 0, minus M. ये हो गया A1 और X1 न्यू बेसिस में. A1 cost is minus M और X1 it is minus 1. Now I want इसके करस्पॉन्डिंग देखिए A1 के करस्पॉन्डिंग 1 0 आना चाहिए और X1 के करस्पॉन्डिंग 0 1 आना चाहिए. अपन जानते हैं कि करस्पॉन्डिंग टू बेसिक एलिमेंट वी मस्ट हैव द यूनिट मैट्रिक्स. तो आप देखेंगे A1 जिसको आप निकाल रहे हैं उसमें क्या था 1 0, उसकी जगह कौन आ रहा है X1. तो इट मींस X1 में यहां क्या आना चाहिए 1 और यहां क्या आना चाहिए, सॉरी A2 को बाहर निकाल रहे हैं. A2 में क्या था 0 और 1, तो X2 की जगह भी क्या आना चाहिए, यहां 1 आना चाहिए और यहां 0 आना चाहिए. यानी 3 को 1 बनाना है यूजिंग की एलिमेंट एंड वी कैन ओनली डू द मल्टीप्लिकेशन एंड डिवीजन. कैसे करेंगे? यूजिंग की एलिमेंट. इस पूरी रो को केवल डिवाइड और मल्टीप्लाई करके से 1 बनाना है यूजिंग की एलिमेंट. तो 3 से डिवाइड कर लें. 3 से डिवाइड करें तो 1 by 3 1 minus 2 by 3 0 minus 1 by 3 0 1 by 3. और इसको 0 बनाना है. कैसे बनाएं? यूजिंग की एलिमेंट रो एंड वी कैन मल्टीप्लाई एंड डिवाइड ओनली बाय की एलिमेंट, देन वी कैन ऐड एंड सब्ट्रैक्ट. इसको R2 R1 पर ऑपरेशन करें. R1 माइनस 1 by 3 R2. इसको 3 से डिवाइड करके फिर सब्ट्रैक्ट कर ले तो 0 हो जाएगा. इस 1 को 0 करना, राइट. देन 1 पूरी रो को 1 by 3 5 minus 1 by 3 it is 14 by 3. It is 14 by 3. It is 0. Minus 2 into 1 by 3 minus minus plus 1 plus 2 by 3, that is 5 by 3. It will be same. Minus 1, ये plus 1, ये 1, ये minus ये आएगी. You can calculate. Again we will calculate Zj minus Cj. ये हो जाएगा -1 0. ये -5m/3 and minus +2/3 +2 यानी कि 6 8/3. It will be m. It is -m/3 +1/3. इसके लिए 0. इसको वैसे कैलकुलेट करने की जरूरत नहीं है क्योंकि हमेशा ही पॉजिटिव आएगा. इट इज ऑलवेज पॉजिटिव क्योंकि जो आर्टिफिशियल वेरिएबल एक बार बाहर निकल गया वो नहीं आएगा क्योंकि ये इससे मल्टीप्लाई होगा तो +m/3 फिर -m और होगा तो और प्लस होगा. तो नाउ यू कैलकुलेट विच इज द मिनिमम, विच इज द मोस्ट नेगेटिव. -5m/3 या ये वाला -m/3 + 1/3 -5m/3 because m is a very large quantity. You assume that m is equals to 10 crore. So in comparison of 1/3, 8/3, it will be higher. So this is your entering vector. Again, we will calculate the key element using ratio of this and this. Only this will be calculated. So it is 14/5 and it is my negative quantity. तो इसको नहीं लेंगे. So it is your key element and corresponding vector is A1. A1 will be outgoing. पहले आपने A1 A2 को बेसिस बनाया था. पहले A2 बाहर निकला, अब A1 बाहर निकले. ठीक है. So we again have the same table. Now the question is x2 basis में x2 x1 cost your cost of x2 is -2 and x1 is -1. देखिए x2 इंटरिंग वेक्टर है और a1 बाहर जा रहा है. a1 के करस्पॉन्डिंग क्या था 1 0. उसकी जगह कौन ले रहा है x2. इट मींस अगेन वी मस्ट हैव हियर 1 and it is 0. In order to make 1, we divide this whole row by 5/3 और key element या 3/5 से आप गुणा कर लें या फिर 5/3 से आप जो है वो मल्टीप्लाई कर दें और डिवाइड कर दें. You will have same result. It will be your 14/5 0 1 -3/5 1/5 3/5 -1/5. ठीक है. फर्स्ट रो को अपन ने 3/5 से मल्टीप्लाई किया या 5/3 से डिवाइड किया. नाउ हाउ वी विल मेक दिस 0. -2/3 को कैसे 0 बनाएंगे यूजिंग की एलिमेंट रो. हाउ विल मेक दिस 0. यहाँ 0 लिखना है हमें x2 के पीछे की एलिमेंट वाली रो का यूज करना है और जो भी मल्टीप्लाई डिवीजन है दैट विल बी विद द की एलिमेंट. क्योंकि जब दो सिस्टम ऑफ इक्वेशन को आप सॉल्व करते हैं ना तो इक्वेशंस को आप गुणा करते हैं. तो जब आप घटाते हैं तो फर्स्ट इक्वेशंस को गुणा करके सेकंड में घटाते हैं. तो यहाँ पे भी यही एल्गोरिथम है. हाँ आई थिंक R1 को अगर 2 लाना है तो 2/5 से मल्टीप्लाई कर लें तो 5 से 5 कैंसिल हो जाएगा 2/3 आ जाएगा और देन इसको ऐड कर लें किसमें R2 में तो अपना पर्पस सॉल्व हो सकता है ना. तो R1 इज 2/5 से मल्टीप्लाई करेंगे तो कितना आएगा 28/15 and 1/3 plus 5 plus 28 that is 33/15. It will be your 1 then इसको 0 -1 को 2/3 से it will be minus 2 by 3, 2 by 5. Then 1 by 3 को 2 by 5 से, that is 2 by 15 minus 3 minus 1 by 30 minus 2 by 15, that is minus 7 by 15. It is 2 by 5 and इनको कैलकुलेट करने की जरूरत नहीं है because once the artificial variable removed it will never enter into the table because of the cost. जो भी चीजें यहाँ तो कम हो रही है तो जो मल्टीप्लाई होगा उसके बाद प्लस क्या होगा माइनस सीजे माइनस ऑफ प्लस तो ऐड होगा प्लस साइन आएगा तो once it is removed it will never enter into the basis due to its cost is minus n. So it is not required कि इसके लिए कैलकुलेट करें, we don't require. So Zj minus Cj it is 0 minus 3 and minus 3 by 5 or minus 5 that is minus plus 6 by 5 plus 2 by 5 8 by 5 it is plus sign minus 2 by 5 plus 7 by 5 that is 5 by 15 minus your 6 by 5 no minus 6 by 5 minus 8 by 5 plus m ऊपर से इसमें भी प्लस m आएगा जो भी संख्या आएगी it will be plus m so it will be positive because m is in now all zj minus cj becomes positive all becomes positive so we have reached at the optimal solution all zj minus cj is greater than 0 so optimal solution is your x1 is 33 by 15 x2 is 14 by 5 because both are in the basis and x3 x4 की जरूरत भी नहीं है these were the surplus variable a1 a2 चाहिए नहीं था अपने को वो तो वैसे artificial variable and z is x1 plus 2x2 इसमें पुट करके वैल्यू फाइंड आउट कर सकते हैं दिस इज योर आंसर दिस इज योर बिग एन मेथड बिल्कुल सिंपल है कहीं पे भी कोई नहीं है कैलकुलेशन पार्ट हो सकता है कई बार इंक्रीज हो जाता है कोफिशिएंट्स के ऊपर डिपेंड करता है अब इसमें एक केस और है अगर आर्टिफिशियल वेरिएबल रिमूव ही नहीं हो पहले ही जा रहे zj माइनस cj हो जाए तब क्या करेंगे फॉर एग्जांपल यहाँ पे ये x2 की जगह a2 है और a2 पॉजिटिव वैल्यू आ रहा है इट मींस आर्टिफिशियल वेरिएबल इज अपीयर्ड इन द बेसिस विथ पॉजिटिव वैल्यू इसका क्या मतलब निकल सकता है इट मींस द प्रॉब्लम हैज नो सॉल्यूशन बिकॉज जिस आर्टिफिशियल को अपन ने जोड़ा था केवल बेसिक फिजिबल सॉल्यूशन को निकालने के लिए उसकी वैल्यू आ गई इट मींस एट दैट टाइम सिस्टम ऑफ इक्वेशन वाज नॉट करेक्ट अगर मान लीजिए For example, this is your A2. तो A2 is 14 by 5. आपने इक्वेशन ली थी x1 plus x2, 3x1 minus something 2x2 minus x4 is equal to 1. That was second equation. इसमें A2 जोड़ा था, ये A2 जोड़ा आपने. अब A2 14 by 15 positive. It means at that time x3x1 minus 2x2 minus x4 was not equals to 1. A2 की वैल्यू आ रही है इसका मतलब पहले जो इक्वेशन लिखी that was wrong. It means this problem has no solution. So when case is when artificial variable in final simplex table appears with positive value, positive non-zero value, then problem has no solution. अगर आर्टिफिशियल वेरिएबल नहीं रिमूव हुआ लेकिन उसकी वैल्यू 0 है तो सॉल्यूशन है समझ में आ रही ये zj माइनस cj सारे पॉजिटिव आने के बाद इन फाइनल सिंप्लेक्स टेबल इफ योर आर्टिफिशियल वेरिएबल अपीयर विद पॉजिटिव नॉन जीरो वैल्यू then we say the problem has no solution. So this is fixed procedure. Before that, you must know what is the basic feasible solution. इसमें कहीं पर भी कोई ambiguity नहीं है. और कई authors different books जो है उसको different तरीके से elaborate करते हैं. We should not be in there. हालांकि the same process को minimization के लिए भी apply कर सकते हैं. जहाँ आप माइनस से जेजे माइनस सीजे मोस्ट नेगेटिव ले रहे हैं वहां मोस्ट पॉजिटिव लेना पड़ेगा पूरे प्रोसेस को रिवर्सिबल. बट वी विल नॉट. इससे बेटर है कि उसको मैक्सिमाइजेशन में कन्वर्ट कर. कई बुक्स जो होते हैं वो कंफ्यूज कर लेते हैं कि मिनिमाइजेशन को भी सॉल्व कर रहे हैं. नो, इट शुड बी कन्वर्टेड इनटू मैक्सिमाइजेशन. मिनिमाइजेशन को भी आप कर सकते हैं. एट दैट टाइम द होल प्रोसीजर विल बी रिवर्स, राइट? सो इट इज बेटर टू बी इन one field that we always use this method for maximization. Here, so any question, any clarification? Okay, thank you. I conclude this. Okay.